Ladies and gentlemen, for those who have not been able to find seats in the room at the moment, there is also up on the exhibition area and sort of an overflow space organized with a screen and seats and coffee, etc. If you would wish to have a seat, then you are welcome to be up there, at least for the time being. Okay, thank you. Welcome one and all. To open this event, I would like to ask our ambassador to Germany, Marja Marelsdóttir, and Pétur Óskarsson, CSO of Business Iceland, please, to come up to the podium. Please, thank you.
Good morning, everyone. Good to see you. Minister, members of German Bundestag, Excellencies, ladies and gentlemen. It is a great pleasure to welcome you who are here in the room and also who are here participating online to our Climate Future Germany-Iceland Clean Energy Summit 2023. It is a great pleasure we have with us here today our Minister, Guðlaugur Þórðarson. He's our Minister for Environment, Energy and Climate. Gulli og Guðlaugur, welcome. And also we will have joining us later on Dr. Robert Habeck, the Vice Chancellor, Federal Minister for Economic Affairs and Climate Action. He will be joining us later on. I'm not going to have a long speech. We have very limited time, but I'm just going to start by thanking also everyone who's participating in the fireside, all the panelists and all the moderators also, and for their input. And I would also like to thank Business Iceland or Green by Iceland, Pétur, for everything, for our close cooperation, preparing this, and also energiewaechter for organizing this, and also all the staff involved. They put a lot of effort into this, so thank you so much for your hard work. And I would also like to thank Landsvirkjun, HS Orka, and On Power for sponsoring this event. I'm looking forward to fruitful discussions. Pétur Óskarsson, the CEO of Business Iceland, is also going to say a few words. But before I give the podium to him, I just want to tell you a bit about this house here. We are here in the common Nordic house. We've been since 1999. And it's called Felleshus, which is the common house. And we have different events here, Nordic events or events like we have today. But we have here an exhibition, which is on the Harten Norden heißt das. It's about heavy metal in the Nordic countries. So I met some people here that actually when they go and look at this exhibition, they go, down memory lane. It's nice to hear that, some people that admired some of these groups that we are exhibiting here. But I really recommend that you go and see this exhibition, and it's a collection of how this has developed in the Nordic countries. But we have quite an agenda today, and once again, thank everyone for your participation. I'm looking forward to fruitful discussions, but now I would like to give the podium to Pétur. Please, Pétur.
Danke, Maria. Sehr geehrte Anwesenden, wir begrüßen Sie heute herzlich willkommen. Wir, die aus Island kommen, freuen uns besonders über die sommerlichen Temperaturen und das große Interesse in diesem zeitgemäßen Energiegipfel in Berlin. Wir bedanken für die Zusammenarbeit mit der Botschaft, Ministerien und vor allem bei der Gesellschaft Energiewaechter, die eine wichtige Rolle gespielt haben in Vorbereitungen des Gipfels. And now into my comfort zone. We have an exciting event here today and discussing the challenges and opportunities in energy and green solutions. As many of you know, Icelanders have been using renewable energy for over a century. Today, we are powering all local electricity and district heating needs from renewable geothermal and hydroelectric resources. But we have not assembled here in Berlin today to discuss the past. We are here to focus on the future and the challenges that we are facing all together. So today, we are bringing together policymakers and industry leaders from both countries. And looking at the audience, I almost feel like we have two national teams here today of Germany and Iceland. But not to compete. We Icelanders do not have a very good experience in competing with the Germans. So we're here to cooperate, and I'm really looking forward to a fruitful conversation here today. I would like finally to thank all the speakers and panelists who are joining us here today, and looking forward to spend the day with you. Thank you.
And Peter, with that, I would like to invite panel 1 to take the stage on the importance of geoscientific research, mapping and developing low temperature areas in Germany, moderated by Sara Borufka. Please, the floor is yours.
Thank you. So, hello again to some of you. I've met a lot of the female members of this audience in the women's session this morning, and I was also told that Nordic countries have a custom of using the first name only. So I will abide gladly by this custom and address all of my panelists by first name. And also I would like to thank Maria and Peter for this warm welcome. And we as guests of the Embassy would also like to thank the staff of the Embassy of Iceland, which has made this possible, thanks to Ruth, Nicole, and all the others, Green by Iceland and Energiewaechter for preparing, organizing, and promoting what I'm confident will be an interesting summit on one of the most important topics of the present day. So, let's not waste any time and jump right into business. Our panelists today are Dr. Inga Möck, who is a leading expert, has more than 20 years of experience in geothermal research, internationally and nationally. She is also the vice president of the German Geothermal Association, which I am a member of. So we actually know each other, and she heads GEOTIS, which is the Geothermal Information System. We have Stefan from Geothermie Neubrandenburg, GTN in short. He has been working in geothermal in this function for 9 years as the head of reservoir engineering and simulation. Next up, we have Professor Ingo Sass, or Ingo for short, who joins us from Potsdam, where he is the head of the geoenergy section at the German Research Center for Geosciences. And he has also held a visiting professorship in Iceland at the School for Renewable Energy Science at the University of Akureyri. From Iceland, joining us, we have Kristen Ingason, who is the manager of Geothermal Plant Division with Manvid, and he has managed projects in countries such as Hungary, the US, Slovakia, Ethiopia, and the Philippines, to name just a few, actually. And he is involved in a training program under the auspices of UNESCO, the Geothermal Training Program. And last but not least, let me introduce also from Iceland, Ani, who is the CEO of ISOR, the Iceland Geosurvey, and prior to that worked as a managing director at Manvit in Budapest, Hungary. He has decades of experience working both nationally and internationally in the public and private sector, actually too much experience to name here. So I won't do that. Let's focus on our panel. But before we jump into the discussion, Ingo would like to hold a short speech in memory of one of the pioneers of bilateral German and Icelandic research, Axel Björnsson, who has sadly recently passed. So,
yeah. Dear Minister, dear Excellencies, dear ladies and gentlemen, it's a duty to me and just shortly take your time to remind us of the death of Axel Björnsson. Professor Axel Björnsson was in a triple function important for that what we have here today. He was a pioneer of geothermal energy in Iceland. He was a pioneer in cooperating between Iceland and Germany, and he did both. He worked on shallow, on low temperature geothermal system as well as on high temperature system. So just some short notes about his vita. He passed away in the age of 80, very silently, 2 weeks ago. And however, he was born in Reykjavik in 1942. And after some ways through school and so on, he did his PhD at the University of Göttingen and finished his PhD in 1972. Then he went back to Iceland, and he had some very important roles. For example, from 1972 to 1990, he was heading in the Icelandic Energy Authority research, the geophysics and the geothermal department, which did not really exist at this time. And in this period, for example, the utilization of low temperature geothermal energy in Iceland extended from about 40% to 85% with respect to the housings. And he was one of the, I would say, inventor of the Krapla geothermal field. He was strongly observing the major eruptions starting from 75, and afterwards the geothermal exploration started. I guess this is an important person, and by the end he did some very important thing also which affects me strongly. He was starting a very, very successful short-running program of RES, Renewable Energy Science. It was a kind of a graduated renewable energy education system from the University of Iceland and from the University of Akureyri, and he was in charge for the geothermal program. So thank you for your audience and for thinking a short second on Axel Björnsson.
thanks, Ingo, for that. And so maybe in the spirit of this pioneer, let's also come up with a discussion that maybe produces some more pioneering thoughts. But I like to keep it simple at the beginning. So the topic of our panel is the importance of geoscientific research, mapping, and developing low temperature areas in Germany. Now, Ingo, I know this sounds like a very basic question, but why is mapping of geothermal resources so important?
Yeah, we are dealing with the geological underground, and the geological underground is variable. So it is a typical and a standard engineering task to explore the underground we have to work with. And due to the variability of the underground, we have to adopt methods, temperatures, and ranges. Therefore, we are also talking about a technology family of geothermal. We cannot say it is just substituting, for example, solar thermal energy. We have different systems, different temperature systems, we have different drilling tasks, and so on. So it is a technology where we need highly educated engineers and scientists, and this will continue.
Great. And Arni, could you maybe speak to the importance of mapping in Iceland and also how maybe you were able to transfer this expertise from Iceland to other regions in the world?
Thank you. Well, not being a geologist, I will do my best. But when I started in this industry almost 2 decades ago now, the first thing I learned was that no two geothermal projects are the same. So you always are, like Ingo said, you're always dealing with the geology, however that is. So you need the sciences, you need the mapping, you need to look into what is there, what is the geology, so you need the geophysicists, etc., etc. So no two systems are the same. You have to look into it, you have to do the mapping, you have to do the research and exploring and all that. But what we have managed to do back in Iceland is actually to transfer our knowledge from this volcanic island into other parts of the world, although they do not have the same geology. So Icelandic scientists have been working here in Europe, in Central Europe, in Africa, Asia, wherever it is, using similar methods.
And I already mentioned, Inga, that you run the GEOTIS system. So maybe from the field, could you speak to its methods, how you acquire data, etc.?
Well, acquiring data, this is part of research, and we also make access to those data. And I think this is not a problem to map, to evaluate existing data, making them available. For me, the key question is how to communicate expert data to the field of geothermal, because geothermal is very interdisciplinary. We have geoscientists, we have engineers, we have economists, and all of them, they have to understand those expert data. And we make access to those geoscientific data in our geothermal information system, which is pretty unique, I think, even in the world. But to guide non-experts, and non-experts are the energy providers in geothermal. They step in now in geothermal. How to make access to reliable data, how to guide them to reliable data so that their project will be successful. This is for me the big question, how to communicate knowledge.
Stefan, you actually work in the field, and from an engineer's point of view, how would you rate the access to open and private mapping data? And what is maybe the business perspective of this as well?
Yeah, the access is very important for us, for all of us, because on one hand, as Inga introduced, it's important to understand the systems because it's not always the same. And the free access especially is important because it's for our company and also for other partners in the industry important to get easy access to this data, not only the maps, but also geophysical data, petrophysical data, all the information that we need to identify potential spots to develop geothermal projects. So it's for everyone important to achieve a fast development for geothermal in Germany and everywhere in the world, of course.
Okay, great. So we actually very briskly focused on the first aspect, which leads us to the second aspect of the panel, which is geoscientific research. So maybe Ingo can speak to one of the most important topics, I think, in a lot of fields, but especially in geothermal, which is the skilled labor shortage in that area and how it could maybe negatively affect the future or even already has, and how we can maybe turn this around so that Iceland and Germany could work together in addressing skilled labor shortage.
Fundamentally in geothermal reservoir exploration.
Oh.
Excuse me. Fundamentally, if we consider geothermal reservoir exploration, we have always a need to combine different methods and disciplines. That means we have to reflect this into education, and the application of such things is for us, as being in a research center, very important to bring our research into practical applications. But the geothermal industry in Germany is comparatively small. We have not even 30,000 people in jobs. And if we consider the plans of the federal government and also the necessities of climate change, we have to enhance this number to a range of about 700,000. And therefore I see here in this community, for example, also joining the experiences in Iceland and probably more lower temperature fields in Germany, that could be a good starter to deepen and enhance our cooperation.
And I think, Kristen, you also work in the education. Maybe you could talk a little bit about the program that you're involved with under the auspices of UNESCO.
Yes, I can. Yeah, I'm involved in this geothermal training program in Iceland, which is though mainly designed for developing countries. So we actually have been helping people from developing countries and do this training program. And actually that has been ongoing since '79, I believe. So it actually has a long history, and a lot of things have been done there. Regarding the geothermal community is quite small. You could see that when you come to conferences, they're more or less all the same faces you recognize from one year to another. But I, though, had this, it was a little bit different in a conference I attended last autumn, following the COVID stuff. But it turned out that there were new faces there. And there were younger people and were more women. So actually it was a kind of being developed in the right direction, I believe. Also, I just want to mention also in the earlier question regarding the importance of mapping. I'm one of the people who get the information from geologists and trying to do something with it. And presently the only way to get the thermal from the ground is a drill. There might be in the future some magical stuff being developed, but this is a reality now. And the drilling cost is actually quite high. And mostly that makes the biggest hurdle in developing new concessions. So, and the importance of having a good mapping, good survey on which to base the well-designed, the targeting, etc., is very important. And as I say, the drilling cost is quite high, but if you drill a successful well, that is usually not considered a problem, the cost. So the importance to drill a successful well is quite big, and that is more or less based on good surveys, good geological surveys.
So this is not exactly a research point, but it just fits so well here. Arni, we talked in the beginning about the incentives in Iceland to kind of mitigate this risk of not finding something. Could you speak to some of the early loan programs?
Absolutely. Maybe if I'm allowed just to touch briefly upon the educational point, because I used to work a lot with GTN in my previous job, and Dr. Peter Seib, who is the managing director there, he sometimes said, well, if you combine the geothermal expertise with the German engineering expertise, you have something. And I truly believe this is the case. So I think there is a field of a possible, what should we say, increased cooperation between the two nations. That is within education. And this is actually something that we worry a bit about in Iceland, because historically, when we have volcanic eruptions, you see that young people, they kind of flock into the universities to learn geology. That is not the case now. That is not the case now. So this is something to be worried about. How do we actually renew the specialization, the expertise within the universities? So I just wanted to touch upon that. Cooperation between Germany and Iceland within the field of education is truly an opportunity, I believe. Back to funding. The fact is that the geothermal development in Iceland started with a political decision. It was a political decision to go for geothermal. There was a debate at the municipality level whether to go with geothermal or gas heating. And luckily, the people that actually were talking about the geothermal, they won the elections. So this was the first. It was a political decision. Secondly, again, a political decision made for the funding. So we made a governmental fund that actually funded the exploration, the drilling, the risky part of geothermal. The municipality could apply. They got funding or not. Let's say they got funding. The project was successful. They paid it back with low interest in a long time. If it was unsuccessful, the loan was written off. So we as a nation took the risk. And this actually developed in a way where more than 90% of all households in Iceland today are heated by geothermal. a political decision, both for going there, but also for the funding. And this is critical. And I've been in this for a while. And the threshold always is the funding for the riskier part of the geothermal project. That is the exploration and the drilling. So, this is happening now elsewhere in the world. You see, like in Africa, we have the Geothermal Risk Mitigation Facility, GRMF. This is moving things. This is happening in Turkey. This is happening in Latin America now. This is not happening in Europe. Why?
Yeah,
Where more than
valid
50%
point.
of the energy needs are for heating and cooling. Come on.
Yeah. Yeah, so there's a very beautiful and simple solution for that. We just need to put it into practice. And I think, Inga, you are a big friend and proponent of putting things into practice. Maybe you can talk a bit about the role of research and maybe also inspire young people to go for geothermal in their decision what to become in this world.
Yeah. As you heard, it's all about lowering the risk. And what is the problem with geothermal projects is this, capex opex ratio. Yeah, we have this high investment cost and high risk at the beginning, and applied research, of course, can help in this situation to reduce the risk. But what do we need? Applied research means pilot projects, operational projects. We only learn from practice, from operation, from exploration, from drilling, from reservoir operation. And what we actually need is, or what I developed is this geothermal play type catalog. And geothermal play type means we have geological analogs worldwide, and when we learn how to explore and exploit a certain geothermal play type, we can adapt this to other places in the world. And here, Iceland and Germany can work together to learn from each other, to develop this geothermal play types and the play type specific exploration and exploitation. I think this is what research can help, assist to reduce this bad ratio between capex and opex.
Wonderful. And maybe elaborating on that point, what would it take for people to go to universities and specifically sign up for programs that end up putting you in the field of geothermal?
Well, we have the problem that we don't have enough students, and I would say it would help that students would come to university and would study the right topic.
So what makes geothermal the right topic?
Well, we need, as I said, it's a very interdisciplinary field. We need geoscientists, engineers, economists. So whatever you are from the background, whatever you are interested, you can step into geothermal research. What we also offer as professors is very interdisciplinary lectures where we combine geosciences and economics. Yeah, so this is what we already combine to help people to think interdisciplinary, but they have to do it. And now it's a little bit provocative maybe, but I think it helps our energy transition more to go to university and to study instead of sticking to the roads.
Okay, great.
That's my opinion.
So the panel also has in its title the term low temperature, and it's actually quite funny because low temperature can mean very different things in different countries, as I've learned preparing for this panel. So Arni, maybe you can tell us what in Iceland is considered low temperature.
Yeah, like I said before, I mean we are a volcanic island, so the temperature is a little bit different back there than what you are used to, maybe in most cases. But we tend to talk about low temperature for everything that is below 120 degrees. So that's low temperature in Iceland.
Okay.
And this is what you commonly use for direct heating, for bathing, etc., etc. Well, you don't bathe in 120, but maybe a little bit less than that.
Hopefully.
Intermediate is what we tend to call 120 to 200. So that is for power production with binary technology, etc. Everything above 200 is high temperature in the Icelandic term, kind of. So, but what is happening today, luckily, is that the lower the temperature, the more, what should we say, opportunities to utilize. And this is different from what it used to be. I mean, the heat pump technology, et cetera, gives us the opportunity to use the hot water, even though it's a lot below 120.
Mm. So those are conditions, of course, that we can only dream of here, but still, why is it important to look at our low temperature areas, Inga?
Well, the one point is it's brilliant that you mentioned the temperature, what is high and low, because this is not scientifically defined, high and low. And therefore we talk of geothermal plate types, because this is a geological environment and this is much better to compare. And of course we have also in Germany geological environments with those high temperatures in the upper Rhine-Graben, for example. For us it would be very interesting to collaborate concerning logging, drilling technologies in high temperature environments, which is for you and for us high temperature. So, but this is dedicated to a geological environment, and this is what we can bring forward. Thinking in geothermal plate types and finding the right operation systems to work in those environments.
And we have some people who work on the field on the panel, so why not address them? So what are your needs and challenges when it comes to the low temperature areas, Stefan?
Oh, for the challenges, the most challenges is to communicate this problem, because when we talk to people and talking about geothermal, they think on Iceland, they think about power production. Then we are not that lucky in Germany. Then we have some areas, as Inga mentioned, in the Rhine-Graben, in Bavaria, where we have high temperatures that are suitable for direct heat usage. But in northern Germany, we are not that lucky. There are just a few areas where we have high temperatures above 80 degrees Celsius. So mostly we are here in the range from 50 to 60 degrees. And when we talk to people, you can have 50 to 60 degrees Celsius. They say, okay, I can't do anything with this. But there's a technology evolved in the last 10, 15 years, and it's now economically feasible, so we can use heat pumps. So large-scale heat pumps can bring the temperatures from these low levels up to high levels on an economical way. So we can produce and develop successful geothermal projects in Germany or northern Germany as well.
So you were involved in planning one of those projects, which has really had a cutting-edge technology and has been also the center of massive attention from the media. Can you speak a little bit about what makes the Schwerin project so unique?
Yeah, thinking about geothermal in northern Germany, there was a large history, like back in the late 80s, early 90s, there have been developments for geothermal in northern Germany, and they are still operating, but for several years there was almost nothing happening, or just a lot of research has been done, a lot of planning has been done, a lot of investigations. But nowadays, due to this project where we showed that drilling doesn't need to be so deep, just 1.3 kilometers, which is much cheaper than in other areas in the world or in the deeper geothermal reservoirs, that makes a large benefit. And there we have shown that it's possible to achieve a high productive reservoir with moderate temperatures and bring this into a district heating grid. So in Schwerin, I think it's about 7 megawatts thermal energy, and keeping in mind that geothermal is always scalable by just increasing flow rate, adding more wells, we can, of course, increase the coverage of the heat demand.
Kristen, you have also worked, I think, in some areas that are not exactly known for their geothermal resources, yet have come to implement this in a very successful way. Could you speak to that?
Yes, I think you referred to project in Hungary. Actually, the drilling success there, we reached water of 80 degrees and above, so it actually was not cold. Now the challenge of utilizing this cold or rather low temperature fluid is actually the output from the well is, well, naturally it's less than for a hotter fluid. So it means that the drilling cost becomes more critical it plays a bigger role. But there are opportunities in utilizing the cold water, and actually coming again to this project in Hungary, even though they are not having water sufficient for the district heating when it's at full load, meaning that when they need the hottest water, which is usually well above 100 degrees, it still can generate quite a lot of energy when the outside temperature is not the lowest. So when it's a partial load on the district heating system, usually you can use colder water.
Great.
So that is obviously an advantage. And one other thing was to bear in mind is that the lower temperature water, the possible chemical problems related to that, they are less compared to the, for example, high enthalpy fluid we are dealing with in Iceland, which means that the wells can be utilized for decades. And we have wells in Iceland which have been operated, I believe, for more than 50 years.
If I may, I think one of the challenges that we are dealing with is that historically people tend to connect geothermal with high temperature and with electricity production. And like Stefan touched upon, I mean, we have a huge opportunity in Europe for the lower temperatures, for district heating, for heating in general. Some of it by a traditional technology like we used to do in Iceland, but some of it with heat pumps. I don't know how many of you know that the Berlin Castle is heated by a geothermal system. The parliament here in Berlin is heated by a geothermal system, both designed by DGN actually. So we can use geothermal in so many places, not commonly known. In Paris they have probably 10 different geothermal district heating systems, etc., etc. And we are sitting on the resource and we are not using it. At the same time, as I said before, where 50% of the energy needs are for heating, and guess what? You can use geothermal for cooling as well. So we have a huge resource untapped.
So I think that's also a point that, Inga, you are extremely passionate about this untapped resource and this thing we just talk about rather than putting it to use. Could you speak to that?
I'm more caring and worrying instead of being passionate because we have so much information already out there, and as Stefan mentioned, we did a lot of research already, mapped and also make access to all this information. Where are actually the pay zones, as we say, yeah. So the good reservoirs, the depositions where you need to drill. What you actually need to do is, as a community, as a municipality, just go to the GEOTIS, geothermal information system, and look just in a general way. Oh, am I in a good geothermal spot or in a not so good geothermal spot? So there's so much information already out there. And what I experience is when I talk with people from municipalities, for example, they say, "Oh, this what is this, GEOTIS?" Or I don't know. So I'm thinking, what else can we do to communicate those data? Are the data too complicated to understand, or do we have to guide them on an easier way? We thought about maybe making like a let's play guiding through GEOTIS, yeah, to make access to how to handle GEOTIS. But this is, I'm asking myself how to motivate people to go to reliable data, and this is another point. There's a lot of data, of course, out there, and there may be more data in future out there, but what is good and reliable data and what are not so good data? And yeah, this brings me back to the point that I mentioned in the beginning, that we have to communicate and guide also the non-experts through the whole knowledge we have. And maybe we have to compile that in a better way. I don't know for now, but there's definitely a lot of knowledge already out there to start in a fast way the heat transition here.
Stefan?
What I might add is we always think about geothermal, or like in most cases we think about in geothermal on the subsurface. So we are interested in what is a pay zone, where is the good areas, how we can utilize it. But we always have to think about to bring this to the energy engineers, to bring it into the surface system, to connect the source with the customer. And this is important because we see it, there's a big lack of people knowing how to bring this into the topic. So what is the energy, or what is the energy demand, what is the heat demand, which can be covered by geothermal, which can be covered by other sources. That's a big point in geothermal where people always forget a little bit. So I encourage people to think also in these areas to develop and to train people.
So I think because we actually managed to cover so many aspects already, I would like to give each of you the chance to maybe speak to what is important in terms of the future of geothermal here in Europe. And then I would like to open the floor for some questions from the audience, if that is okay. So maybe starting with Inga.
Yeah. In the past, we thought more in, we want to reach a certain temperature range and we look to a certain depth. What we learn from our projects now is, yes, drilling, having a target is good, but having a second and a third target is even better to have a backup solution. And this brings us into a whole bunch of geothermal technologies, direct use or direct use plus heat pump, or maybe indirect use. So what we should do in future is, when we explore the subsurface, not thinking only in one technology, not only in one reservoir horizon, in one temperature level, but in the whole geothermal gradient, let's say, and make the best out of it what you get. Yeah, so that we don't have a failure of a project, but just it's maybe a different project, different than planned. And the Hamburg-Wilhelmsburg project is such an example where they aim to drill in a deeper section. Now they want to operate in a shallower section, and it's a working project. So this is a brilliant example for that.
Wonderful. Thank you so much.
Yeah, Inga, you said a lot that I wanted to say, but yeah, might be there are some things, of course, to bring the geothermal forward, to make it faster, to develop it. Of course, it's important to map, to ongoing mapping, but it's also important to drill and to start exploration. And therefore, of course, funding is necessary, or as a big opportunity to reduce the risk for the clients or for the developers to bring geothermal forward.
Wonderful, thank you.
Yeah, as being a researcher, I have always a lot of things to research, but let's look for the priorities a little bit. So what we think is very important, that on the side of the computer science, the reservoir engineering, the geological engineering, and the geological exploration, which is packed into numerical models, shall learn to talk to the energy system models. So we call this co-simulation. This is really, really an important point, because I think that the energy consumer, or we think that the energy consumer not necessarily has to know what about the underground properties and so on, because you normally never have this. If you're driving a car, you will not take care about how the gasoline is refined or anything else. So I think we have to take this and bring it into the system. Then we have Germany is very heterogeneous, more heterogeneous in geology than Iceland, also on the same scale. And so we have multifold of reservoir systems and so on. And we have one underexplored system. This is especially for heat storage and for probably later on hotter applications. It's the crystalline basement. So we have the highest geothermal potential, by far exceeding the other ones in the crystalline basement. So a strong future activity and a fundamental research shall be in the crystalline basement. And at least we have to, and if you do statistics, there is, of course, a risk in geothermal drilling. In any drilling, there is a risk. And if you do statistics, you will learn that the geothermal success in geothermal drillings globally is a little bit higher than in oil and gas drilling. So this is probably not known. That gives a glance on how media is acting with us, with the geothermal industry and so on. So fundamentally, geothermal drilling is some percent more successful than oil and gas drilling, and therefore we have very clear things we have to do. I think we have to put the basis for governmental funding and risk buffering into this. And there's also some research and consultancy necessary, which should be done by this.
There's a problem with the mic. Okay. Let's try all of them.
Okay.
Okay.
Well, I'll go for this one. Yeah, I think we are more or less all on the same page. What is important is to not to concentrate on one particular solution. We need to look at all the possibilities. Looking at how we can utilize relatively cold fluid, and I mean we have, for example, in Iceland we have district heating system which are operating at I think it's like 50 or 60 degrees hot water, so successfully been operated. And we also need to look at them and continue exploring possibilities of EGS and things like that, even though that is in the future, and well, probably in the future. Another thing which is critical, I mentioned earlier, that is related to the cost of exploration, and that can be approached at least in two ways. Firstly, by better investigation, as I mentioned earlier, to have a better surveys, to be able to target the resource better and increase, therefore, the likelihood of a successful well. As Ingo said, the success rate in geothermal is quite high, but when comparing this though to oil and gas, we have this disadvantage is that the value from a well is usually considerably lower than what you may get from oil and gas. So they can afford actually many different things in drilling which we cannot afford in geothermal. Drilling in Germany actually is quite expensive. I don't know, this probably is a delicate matter to touch on, but there might be some worth investigating how come it seems to be more expensive than in the neighboring countries. And yeah, and also further development in the EGS, as I mentioned, that is well, yeah, probably is going to take quite some years yet. Even it has been developed for quite many years, but probably needs some more years before it can be implemented commercially. But if that resource opens up, it's a huge one, and we could have a lot of opportunities there.
Yeah, well, it's always a challenge to be the last, but I mean, I think we agree that Europe has a lot of untapped geothermal resources. There are different technologies where you can actually utilize those resources. We have the expertise, whether that is from a geological point of view or engineering point of view. What are we lacking? We are lacking the political will and political decision, in my mind, and the funding. Because, I mean, it's also about independency. Do we want to be where we are? Or do we want to tap into our own natural resources? They are there. And like Inga said, we probably need to communicate better, but we have, though, been communicating this for decades to the politics, to the financial institutions. The perceived risk in geothermal is more than the actual risk, and this is a fact. So it's a political decision. Let's go and utilize our own resources. That's what it is about, in my mind. The future is bright. It's a question if we want to be there or not.
Yeah, I think that's a wonderfully succinct end to the official part of the panel. But whoa, we have many questions, so let me try this with the mic. I think you went up first. So.
Good morning, everyone. I'm a student from Duisburg-Essen University. You're talking about that you don't have a lot of students who are interested in this topic. I think also so, but at least I'm here. So we do have some people who are interested and who want to change the world. It's a very interesting topic, I think, and thank you for such information. And my question is next. How could we use the geothermal energy for instance for the carbon capture and storage, carbon capture and utilization on the basis of waste incineration plant, for instance. Do you have any examples in this area? Thank you.
Maybe the Icelandic colleagues will head up, but there's a project in Iceland where they capture the CO2 and store it into the basalt rocks, where it just precipitate and becomes part of the formation. So that's one possibility, but it's quite young technology in this part.
I mean the I mean the heat energy demand. So because of this technology of carbon capture and storage needs a lot of heating, a lot of heat energy. And could you to give me an example or to explain how can we use the geothermal systems for instance for TCO and CCS?
I don't know if I'm going to be able to partly answer your question, but I think later on the agenda today is talk on an Icelandic technology being developed, and the company is called Carbfix, where they actually inject the CO2 into the ground again, and it makes a rock formation. So that's one way to do it, and there are other technologies as well, where you are pumping the CO2 into the ground and keeping it there as a gas or as a liquid. So I mean there are different technologies being developed now to capture the CO2 from geothermal and from other aspects as well. But I know one of the Icelanders, Kristinn, is going to do a little bit of a speech on this technology later today.
Okay, since we're actually short on time, would you mind passing the mic to the person behind you?
Hi.
Yeah.
Joanna Bryson, I'm a professor at Hertie School here in technology policy. And I was really interested in this question about why, I realize, as you say, sensitive topic, but why German municipalities don't even know that this information is exposed. In the United States, a lot of the people that would be likely to be promoting that would actually be the companies that would be making money out of being the ones who were doing the drilling. So I'm wondering if there's some kind of structural problem, why that communication isn't happening. Is it because there isn't anyone who's particularly motivated? I mean, if it is being done by government, the drilling also is being done by government, then we need to make it somebody's job to do that promotion. But if there's corporations involved, I don't see why they wouldn't get out and say, hey, do you know we could do this for you?
So maybe Inga?
Well, one reason might be that the topic geothermal energy is totally new for the municipality. So this is actually, since 1 year, they deal now with geothermal energy. But still, I'm surprised that they don't know about this geothermal information system, because it tells you also something about the geological subsurface, which might be interesting for municipalities in different ways. I think it has to do with expertise in the municipalities, because they didn't need to care for exploration or subsurface.
But the point is that, so they aren't pulling for whatever reason. Why isn't someone pushing?
Oh, yeah.
Why isn't there someone who would make money doing the pushing and say, hey, here, I have some information that will help you?
Yeah, making a little bit marketing and advertisement, right? Yeah. This is maybe what we actually need, really telling it again and again. It's a little bit like, when you're a researcher, you think, oh, I explained this one time, then you think, oh, they should have understood, yeah? So it's also a little bit an own failure, yes? So this is what I would commit, but you are right. We need actually continuous communication, like a little bit like marketing, telling again and again the story. Yeah, that's right.
So I think also we have a question from Professor Dr. Susanne Bauter.
Yes, thanks a lot. I'm from the German Research Center for Geosciences. And I would like to touch upon perspectives and perception. And this links to also what Inga raised earlier, and what I think several of you touched upon, the expectation of how many skilled workers at all levels, I take that very broad, will be needed in geothermal. At the same time, we see, for example, at German universities, that when a chair retires in reservoir technology, that the direction is changed to something like biogeochemistry, which is equally valid and also necessary. It's a choice, a valid choice that the universities make. So, but why is this changed, and how are we then going to educate our students? And I think this touches upon then the perception. I think somehow or other geothermal is binned with everything that goes in the subsurface, which in Germany is seen critical. So it's an open question. How can we go about changing the perception so that we offer a perspective?
So, would like to answer that. I think this may have to be the final question. We're running out of time.
Thank you, Susanne. In my world, because I have an industry background from drilling and consulting, one major point is that we educate the already graduated persons who are in practice, especially the engineers, and that we collect them. So a joint program for graduates from the professionals would be very, very helpful. And then on the other hand, this is really also my personal experience, because I'm also still a professor at a university. The toxic fracking discussion in Germany is really not helpful to get younger people into our field of research and engineering. It is really a problem if an oil industry topic is really damaging the image of our energy and our process, because we use the same technology to get to the reservoir, drilling, more or less. And this is, and we really experienced a drawdown of the freshman numbers with increasing fracking discussion. And so we need to work on, and this is a marketing point, we need really to work on to improve, enhance the image of geothermal energy. And therefore, it is important that we have, I'm really convinced on this, that we have a science, correlation in the projects, that we do this proper and right, and in different fields.
So I believe you had one final question.
Oh.
We have 3 minutes left, so.
Okay, I'll hurry up. So I'm Thomas Kohl, and I'm leading the Helmholtz geothermal program in the research topic energy. And we have at KIT the largest, or initiated possibly the largest research projects that we have, and jointly with other, with the GFZ. But there are two topics that I would like to raise. The one is we might speak also on new topics and new technologies like storage, high temperature storage. I think this is also a new technology that needs to come. So just suffering from the heat that we have right now in Berlin, so we might possibly also inject this heat in the underground. So this requires completely different geological setting than we have on production. And another thing is that we are here at KIT in Karlsruhe in the Rheingraben, which is one of the hottest spots, maybe the hottest anomalies in Germany and Central Europe, with temperatures above 200 degrees. But these systems are coming from fractured systems. So these are fractured faulted systems as they are in Iceland. And I think this is also a kind of a joint expertise that we can explore in future, and how to operate fractured systems safely at long term. And this is also to get the acceptance in the population running.
Okay, thank you. So thanks for that input. I think we have to wrap this up. So 2 minutes left. So I would like to thank all of our panelists for a very lively and I think enlightening discussion to kick off this day. And of course, in this room, we are preaching to the converted, right? You wouldn't be joining us here if you weren't interested in renewables. So maybe one nice takeaway from this discussion could be to talk to other people about geothermal and what you have learned today, and just carry this knowledge into parts of society that may be skeptical about geothermal, because that's the only way we can propel change. So thank you very much for your time, and enjoy the rest of the summit.
Thank you, Sarah, and your panelists. It's my honor to warmly welcome Vice Chancellor and Federal Minister for Economic Affairs and Climate Action, Dr. Robert Habeck, to deliver a keynote address. Please, Minister.
So, right, good morning everyone, and dear friends from Iceland, dear ministers, welcome in Berlin and in Germany. Thank you very much for arranging this conference. Thank you very much for being here. When we walked in, we just discussed, just in the 2 minutes we had, the possibilities of cooperation of the future, and we identified one problem. Iceland and Germany, they are not neighbors. They are quite far away, but in a way, of course, we are neighbors, as there's only water between us. You said, well, this is one thing we won't change, and we won't change. Therefore, we, of course, have to look into the prospects of cooperation, meaning technical knowledge, meaning planning, and, of course, then deep economic and energy and climate action cooperation. And from a German perspective, especially from a perspective of the German Minister for Climate Action, we are jealous. We look at Iceland and see your endless possibilities. I mean, you have volcanoes, we won't, and we don't have. Your heating system is decarbonized. Your use of renewable energy, hydrogen, or hydro, and geothermal is almost endless. We, as you know, the ones who have visited Germany, we need wind turbines on and offshore and solar energy to decarbonize our economy and in our electric system, and then use the electricity also to decarbonize heating and mobility. And that is a challenge, of course, as we are still a very populated and very high industrialized country. Not all of the countries in Europe still are, but we are. We have high energy-intensive industries. We have steel industry, we have chemical industry, we have aluminium industry, and we are trying to bring more industries to Germany as well. Semiconductors, for example, they also will use energy. So the possibility of getting along with fewer energy is not really given and not the aim, and the possibilities are nothing compared with the possibilities in Iceland. But of course, we want to make use of the best of it. For the ones coming from Iceland and maybe haven't heard the figures, we are now producing something like 50% renewable energy for our electric system. 50% for Germany, that is something, but it took 20 years, 25 years to increase the volume up to 50%. And the aim is to produce 80% of renewable energy in 2030, so in 7 years' time. And the amount of electric energy will increase due to heating pumps and electric vehicles. So you see the challenge. We have to treedouble the speed of the scale-up of renewable energy, and that is wind turbines and solar. Wind turbines onshore and offshore. Onshore, it's always a problem due to bird directives and environmental protections, and of course not all of the people in Germany are fans of wind turbines. And I admit they are changing the landscape. The memory of your childhood becomes different if you look to the horizon and see some windmills. So, of course, there's a cultural problem there. But what shall I say? We have to do that. And we have to do that on 2% of the space of Germany, only 2%. But, of course, only 2%, you can see the windmills over hundreds and maybe thousands of meters. So there is a challenge, of course. But I would say, positively speaking, we are on the way of getting along. We have changed the direction. The amount of windmills in planning processes and that are erected, they are going up, the numbers. And with solar, we are on the right path. We are seeing figures as never before in Germany. So this is really something. But this is just to give you an impression where we are standing and what we are doing. Coming to the potential parts of a cooperation between Germany and Iceland, offshore may be the most important thing. You know that, maybe you know that the German plans for increasing the volume of Offshore wind turbines is up to 30 gigawatt in 2030. Just to give you an impression, it's always almost the same as as onshore. We have now 8 gigawatt offshore windmills installed, 8 gigawatt, and it took 20 years. Now we will increase the volume up to 30 in 2030, so 7 years' time, 3 times the volume, and then going up to 70 gigawatt in 2030. And this is only Germany. The other North Sea neighbors, Denmark, Netherlands, Belgium, Great Britain, Norway, all together we have plans up to 270 gigawatt in 2040. So this is an enormous capacity that is there. And the good thing is that we are now in the neighborhood of the North Sea region. We are coming to a close cooperation, developing the grid, developing the hydrogen pipeline between the different offshore wind farms is now in the planning process. And this only makes sense because if every nation is planning its own grid, then it would be very, very ineffective. So this is really a step forward, and there the northwest European side can show what it is able to do. And maybe that is also a possibility for Iceland to join us, to step in. Of course, the distance between, I don't know, let's say Scotland and France and Germany is nothing compared to the distance to Ireland. But I mean, in the end, it's grid, and I haven't looked it through, but it might be a possibility that we at least think and discuss it. If you have wishes, possibilities there, at least the investment possibilities are there for your companies to invest also in European wind farms. So the offshore cooperation might be one concrete possible step to go really into common projects together. Then the second one is geothermal. I just went along during my remarks to the electric system. One of the problems in Germany coming to climate action is that more than 30% of the CO2 emissions are coming from the heating system. It's not the industries, it's the heating system. And of course, the difference between the industries, let's look at the steel sector, very strong in Germany, still very strong. It stands for 8% of the CO2 emissions, only the steel sector, but it's 4 companies. So if I want to decarbonize the steel sectors, I have to talk with 4 CEOs. And then I find an agreement or not, but it's 4 CEOs. They have, of course, also their boards. And if we come to an agreement, they can't give me the guarantee that this will work out. And I, of course, have to go to the Chancellor and the Minister of Finance. Well, you know what I'm talking about. But it's nothing compared to the discussion I have with 40 million households in Germany. And they are all different. They have all their different needs. Their houses are isolated or not. They are old or not, whatever. So we are now facing a quite challenging debate in Germany about that, and it's mainly focused on heating pumps and the electrification of the heating system. And the debate was rough in the last weeks and months. The German participants of this audience know what I'm talking about. But of course, this is only part of the change we're going through, and maybe not the most important one. This is not wrong. It's an important part. But in district heating systems, I think we have a better chance for decarbonizing our systems. And this means that we use different sources in district heating systems that they can also differ, biomass and power to heat, for example, or big heating pumps. But geothermal is, of course, one of the biggest and greatest and cheapest possibilities if we can manage it. And there we have some experience in Germany, but nothing compared to yours. So we want to increase that. We want to increase the numbers of heating systems, also the extension of the heating systems. There are different funding programs on the way and existing, but of course we want to also make use more of geothermal. So this is the second point of cooperation I can imagine that we can work on, using your experience, bring it to Germany. Maybe there are companies, maybe there are experts, there are research institutes here that bring their knowledge to Germany, and of course we have also some knowledge and can cooperate there. Vice versa. Second part, I think we should increase our cooperation in all forms of research and industrial cooperation. The idea behind the economic idea behind the decarbonization is not climate action in itself, but inventing the new systems for Europe. And inventing the new systems means also the production side is of highest importance. So all the possibilities we have, smart metering, electrolyzers, batteries, and so on, I want to see production sites here in Germany and in Europe. And this is maybe the third part. It's not direct in the heart of climate action, but it belongs to climate action that our companies can cooperate and make business models out of that. And the fourth I can imagine is CCS. This is of course obvious that we have some sectors in the industries that from the knowledge of today are impossible to decarbonize. Cement, for example. And there are other emissions that we haven't found the possibility to get rid of them with the systems we have, hydrogen, electrification, renewable energy. We need CCS. And also there, Germany has some restrictions. Right now, it's not possible to apart from research, to really use the technique in Germany. We're going to change that in the course of this year. And then the question is, are there sites in Europe and in Germany where we can bring the CO2 apart from making use of it, CCU? And I know that Iceland has made a decision that you are on your way of bringing storage capacities to the market, and that might also be interesting for German companies. There are other ones as well. You know of Norway, your neighbor, your friendly neighbor, if I can say so. You know of Denmark, maybe. But well, this is in the end a business model and a market that is developing there, and including Iceland and the possibilities of Iceland in the market, I think always makes sense. What I'm trying to say is we have ambitious targets in Germany. We are well underway, on our way. It's complicated as it always is, but I couldn't think of a better partner for a close cooperation than Iceland. And the distance, the local distance, the geographical distance we have does not mean that we have to have an emotional and political distance. So welcome in Berlin. Let's overcome the distance. Thank you very much.
Thank you, Minister Habeck. And it's now my great pleasure to welcome onto the podium the Minister for Environment, Energy and Climate, Guðlaugur Þór Þórðarson. Guðlaugur Þór, gjörðu svo vel.
Thank you. Dear Minister, members of the German Bundestag, Excellencies, ladies and gentlemen. It's a pleasure for me to be here with you today at this event organized by the Embassy of Iceland in Berlin and Green by Iceland with the title Our Climate Future. Iceland has set itself a clear vision for sustainable energy future as outlined in our long-term energy policy to the year 2050. Two key pillars of the policy are energy security and sustainability, reflecting the need to pursue both in harmony. We have enhanced our ambition when it comes to the objectives of the Paris Agreement to achieve at least 55% net greenhouse gas emission reduction by 2030 compared to 1990, by acting jointly with the European Union and its member states and Norway. Our goal is to become carbon neutral and the first fossil fuel-free country by 2040. I believe we have a lot to offer in energy matters. In Iceland, you can get a peek into a future which everyone strives for now. A fully renewable electricity and heating system with close to zero carbon footprint. Iceland ventured through the energy transition of these sectors decades ago, after the oil crisis of the time, and some of them also almost 100 years ago. And now, today, over 85% of primary energy use in Iceland comes from renewable resources. We don't use any nuclear power or natural gas. The only fossil fuels in use today are in the mobile sectors, transports on land, ships, and aviation. There we also are hard at work and have the second highest rate per capita of new registrations of electric and plug-in hybrid cars worldwide. We have achieved this mainly through two policies. First, we have for a long time had financial incentives for customers to buy low and zero emission cars in the form of tax and fee breaks. Second, the government has supported building a network of charging points, not least in rural areas. We have done this by grants that match initiatives by power companies and private actors. This has helped us to get maximum benefit for public money. A comprehensive network of charging points is of key importance in sparsely populated country like Iceland, as any geographical bottleneck has bad effect on drivers' confidence. For you who don't know, it's well known in Iceland that charging and anxiety, hleðslukviði in Iceland, which is important to get rid of. Iceland continues to lead the world in harnessing geothermal energy in and around the capital, Reykjavik. There is an entire value chain of geothermal utilization at work. Before we started using our geothermal resource for district heating in 1930s, Reykjavik would often be hidden under a dark cloud of coal dust. Since then, we have built up greenhouses, we enjoy warm outdoor swimming pools year-round, produce electricity in high heat areas, and harness endless opportunities for cascading use of geothermal value streams, including in low heat areas, like we have in Europe and in Germany. Our big push in the energy transition, moving away from the imported fossil fuel of domestic renewable resources, was in the 1970s. In a couple of decades, heating of houses with fossil fuels was replaced with clean geothermal energy. In the 70s, the term climate change was not in our vocabulary, and nobody was talking about the connection between global warming and CO2. Our main focus then was on being independent from imported oil by using the energy under our very feet, which had the advantage of being clean and more convenient than oil. The social and economic benefits of this development have been substantial. The macroeconomic benefits of the geothermal district heating system annually amount to around 7% of our GDP. This is not only because the energy prices of geothermal are usually lower than electricity or import fossil fuel for house heating, it is also that the quality of life is substantially improved. We are keenly aware that we are now in the midst of converging crisis of energy security and climate change. There is a severe energy crisis stemming from Russia's brutal invasion of Ukraine. The climate crisis is blooming larger than ever. Notably, the key addressing both issues lies in renewable energy. The crisis has accelerated even more the drive for renewable energy development for the purpose of enhancing energy security and fighting climate change. In Iceland, we are fortunate not to be dependent on Russian oil or gas. Having abundant domestic renewable energy supply enables us to meet 100% of our electricity and heating needs from such resources. The fact that geothermal energy is a domestic source lends it a great role in energy security. It provides a secure and stable energy supply, reducing the need to import non-renewable energy and therefore increasing energy independence. We know there are vast opportunities in Europe for geothermal utilization. I am impressed by Germany's technological developments in harnessing low heat resources. The benefits from drawing on geothermal energy are undeniable and fit well with the EU's goal of promoting secure and clean energy and environmental long-term policies. Geothermal district heating has great potential of replacing a significant part of EU's demand for imported energy. There is a clear potential to expand the use of geothermal, both for new district heating systems as well as the use of geothermal instead of fossil fuel in systems that are already operational. But despite being blessed with abundant renewable energy resources in Iceland, we also acknowledge that we need to do more and are committed to do so, including by sharing our experience and green solutions with others. And what we need to do, we need to scale up existing green solutions. And we also need innovation if we want to succeed in averting catastrophic climate change. For Iceland, that brings us again to geothermal energy and technology. Some years ago, Icelandic scientists sought solutions to curb sulfur and carbon emission from geothermal energy productions. These are natural emissions, but concentrated and speeded up by geothermal plants. The result is CarbFix, a revolutionary technology in carbon capture and storage, where CO2 is captured from steam, pumped underground, and turned into minerals in porous basaltic rock. The technology is rapidly evolving and now used for direct air capture at a site near Reykjavik. Big grants from the EU and others are helping us to develop this technology further. This is exciting, but so are other cutting-edge research and innovation projects. The next frontier in the geothermal value chain is superhot geothermal energy. We have endless energy in the mantle of the earth, and Iceland is looking to unlock this vast potential. When we achieve it, it will be a game changer. However, this is something which we cannot do on our own. We need partners to work with, and I can think of no better partner than Germany to work towards this next generation of geothermal energy. We need German science and precision engineering. There is a project in Iceland, Krafla Magma Testbed, also known as KMT, that is working towards building a research infrastructure in the northeast of Iceland, dedicated to drilling into magma. I would like to use this opportunity to invite the German government to join hands with us in solving the challenges associated with harnessing this extreme energy potential. Partnerships and cooperation are essential for solving the daunting tasks ahead. In this regard, Iceland is fortunate, even though we are a bit far away, to have a long-lasting bond and friendship with Germany. I hope that we can build on that connection and strengthen our ties in the area even further. Let us build a clean energy and a stable climate future together. Thank you.
Thank you, ministers. Now, if you're a little bit ahead schedule, which will be to the benefit of our next segment, which is an exciting fireside discussion with moderated with Dr. David Bote, with Kristín Linda Árnadóttir and Professor Antil Witjes. So when the time allows for it, please feel free, Dr. Bote, Kristín Linda, and Professor Witjes.
Apologies for a small technical glitch. I was hoping to get a microphone, but we'll find this way. We're a bit ahead of schedule. Okay, so first of all, welcome to this fireside talk. So obviously it was the first measure we did to decrease the carbon footprint of this whole event, just get rid of the fire, and so you just have to refer to an imaginary fire. But still we want to have it a kind of cozy talking atmosphere here, and talking about the our climate future, climate protection, energy transition, and economic prosperity, a challenge or an opportunity. And the idea of this talk is basically to fill a gap, because we had now this big political sphere, the big objectives, and we also have a lot of panels, already one this morning and others later today, on detailed technical solutions. And in between is this layer of society and economy where actually the transition has to happen, where basically the technology options have to be implemented in order to achieve the political goals. And at least my impression is over the last years that this is maybe the layer where the biggest hurdles are, where we risk to get stuck, that we are losing this momentum on this element. We know what the technologies are, we know what the options are we could use, and we know we have a clear formulated target. We just heard it again from the ministers, and we know where we want to get to. But somehow we haven't yet unleashed this potential and really get the momentum going. And I think talking about this would be the idea for me to use this talk for having maybe, I'm not sure if we can solve it in the next 40 minutes, but at least maybe we can collect some ideas. And I'm very happy to have two perfect experts for this here with me. First is Professor Dr. Antje Boetius. She's German polar and deep sea researcher and director of the Alfred Wegener Institute. She studies the impact of climate change, biodiversity losses, and ocean health. And you're also a member of the National Academy of Science, Leopoldina. And what I found very interesting, you also collaborate with art, theater, and film, so the culture industry, with focus on the relationship between humanity and nature. So exactly this gap between society and the science. And we also have Kristin Linda Árnadóttir. She is the Deputy CEO of Landsvirkjun, the national power company of Iceland. You're also the chairwoman, I guess, of the Federation of Energy and Utility Companies in Iceland. And what I also found very interesting, you have been for many years the Director General at the Environment Agency of Iceland for over 12 years, so also have looked at this from a official function role. So, thank you very much. And just to get us starting, I mean, I think we just heard the recommitment of the politicians, like there is a strong commitment to fighting climate change. Antje, you're working on it as an researcher. You can tell us more about this. If you reflect, if you see what is going on the political sphere, are you satisfied? Do you think like we are on the right track, or is there something else you would like us to do?
Well, okay, so I'm an Earth system scientist. That means that I get to talk about the apocalypse of not being on the right track. And that's, of course, an important part that we need as humans always when we have to make large decisions. We want to know, of course, what is in for us, but also we need that fear of a future that we don't want. That has always been that way. And the Minister of Iceland has mentioned that. You can always go on the wrong track, and then eventually you can go to the right track. The good thing is that the track we want to be on has been decided at the highest levels of all nations together, both for climate and biodiversity crisis, and if you want to expand it to the Sustainable Development Goals, also for the crises of hunger and security and children's education and women and all of that. So we have political negotiations, political goals. And the question now is, can the nations, as the ultimate governing body, can they do the right thing for their citizens? And where are they stuck? Where are they not doing the right thing? And then we have to see that for the ultimate goal that we have for climate, to stay much below 2 degrees or at best, and some Icelandic politicians have fought that through as a Paris climate goal, stay best below 1.5 or reach 1.5 just shortly before we go to climate neutrality. That path we are not reaching to the best of scientific knowledge. We are diverting from it. We could still reach it with a gigantic effort, very costly, but it doesn't look great. And then, of course, we have to think apocalypse plus survival plus transformation all together. That's where we stand today.
Okay. Apocalypse are words which have a kind of
I mean,
strong
anyone who has seen the pictures of New York, has seen the flooding in Pakistan, has taken the stock of children that are in poverty again, that has increased, that to me is the word apocalypse.
Very good. Christine, Mr. Habeck said like he's jealous on Iceland because it always feels like you are much more ahead than many other countries, particularly in Germany. But still, you still also have something to. Can you give us a quick summary? What do you think? Where do you stand as a nation with regard to fulfilling your targets, and also what are the remaining construction sites?
Well, I think it's very important to start at the beginning. We are in a very fortunate place now, as the minister said. However, we did not reach that place just by sort of like, it did not accidentally happen. It was a political decision, and it was not a consensus decision either. So many people at that time thought, well, I think it's better to have oil. That is a very proven concept. You know, we know how it works. Geothermal, you know, it's too hot or not too hot, and what is hot and what is low temperature. You know the discussion here. So it was not a decision that was taken very quietly or lightly. We tell the success stories now, but I think it's also important that we tell the story. It was not very simple. You know, we have wells that did not succeed, didn't give us the warm water. Some wells are just like almost looked at as a natural phenomenon because something happened and they may be blown up or something like that. But you have to look at it that way. We are in this place because we made decision, we made some mistakes, we put money into it, and we were very courageous, because the easy part then, to be very sure of what you are doing, would have to be to taking oil or coal or keeping on the same path as everybody else. But today we are in a very fortunate position. However, like 85% of our primary energy is then green, but we have 15% left. The government has made a very clear goal. We want to be taking out fossil fuel by 2040. And that means road transport. That means our fishery industry. So if you just talk about the roads, as you all know, Iceland is a rather large country with very few inhabitants, and we live around the country, so we have to travel. So rails are not very, we are not enough of us there yet. We are still trying to make more babies. But we need to be very realistic of how we're going to do this, and there we will need social acceptance, as same as here. So we also, as Icelanders, need to be watch out for the danger of thinking about the past, and we've done so great, and not thinking that we have a very steep hill ahead of us, because it is a hill also for us.
Just briefly comment on it. I find it very important that you always tell the story of energy in your nation, in a country. When we forget it in Germany often, but when you go back to literature and facts about the electrification, so I come from Darmstadt, Frankfurt, where the first city that got electrified, and you read texts about electrification as if it was something from hell, from the devil, and all of the damage people could take, and the immense first investment that someone had to shoulder. And we forgot all about that. So I find it very, very good that you tell the story, how easy it is as humans. You decide for one path, you take the risk, and then you are rewarded or you fail. And we just have to understand the path we're on is now that it was good for some time, but now it leads to ultimate failure. But what we also know about humans is so hard to make us change one path for another, especially when it's about cheap energy. And that's the key thing we'll have to solve, that problem of transformation activation. And the first panel this morning said it very clearly, communication and clarity and education in it, but also investing in a big PR machine that must ultimately be bigger than that of fossil fuel industry, and that is tough. That is what is needed, and it's not there yet.
And I think that's a very reassuring message as well for us in Germany, that we see that others have had the same discussions and the public opposition on their developments, but that we now have a case as a good example of what the benefits could be if you endure these kind of discussions and stay to and take the courage and do the decisions. And I think if I could have, when I see these Icelandic cases, I think it's often so reduced of, it's this odd country in the north who happens to have so much energy, and it's so easy for them. But I think you cannot spread the word often enough, like how difficult it was for you to get there. And if there's, I don't know if there's a lesson learned or something you can share with us also, how you managed to handle these kind of discussion and to get this momentum, then obviously that would be something we would be very eager to learn from you as well.
Yeah, but I think in that you need to think about the spirit of the nation when we were taking these decisions. We were a relatively newly independent nation, so independence meant a lot for us. And during the oil crisis, you could see that that was a real hindrance to our independence. So I think that played into our sort of like national pride also, that we wanted to achieve that. And that brings us to the importance of sort of like gaining the momentum and reading the room, reading the nation, and tapping into what they want and also showing them the path. Because that was the path towards this energy system that we have today. So there is no simple solution. However, if we look at it from today's perspective, we got there by gaining knowledge, believing in science, but also sort of like realizing that we will not finalize it, all of it at once, and having the courage to do it. But I think that this independence issue was a strong driver also for us.
When I visit Iceland, and I do that quite often, I'm always amazed how many people know each other. So I had the luck to travel also with both presidents, the president of Germany and of Iceland. And so you go everywhere, and then small kids run up to the Icelandic president, and they know that him and the father has played soccer together and these kinds of things, so that the German president was a bit envious after the visit, how easy it can be and how nice with the people. And I think this people thing is so important. So of course, then everyone thinks, yeah, how should that be possible in Germany? But the level of communities, cities, communities, the system that we have with neighbors, with mayors, so that where action takes place, where these few 10,000 people are in reach and one knows each other, is an essential sphere for humans to take decisions and pull them through. And we should not forget that. So in my belief, okay, I'm a deep sea and polar researcher, is research about landscapes without humans, but I learn from others, and I learn that this sphere of humans that you can reach, where you can talk in private, also help to get rid of blockades, that is essential, and we need to have more power in the cities and communities to reach the transformation. That's what I think we can learn from you.
And very interesting that you said, like, it's also this element of independent which created this momentum. Maybe that's also something for us to learn, that while climate catastrophe might be the main driver, it might, but in marketing terms, maybe not the best term. And I'm just wondering if maybe this element of self-sufficiency, independence, could also help to accelerate the momentum. What do you think?
Well, I of course look at Europe, and you're very interconnected, and that for us is also very admirable. So I was mainly talking into the past and what our past decision sort of like pushed us towards being more courageous and sort of like standing a little bit taller maybe. If you look at Europe now, if you look at even in Iceland, I think interconnection is hugely important. For of course, low temperature use of heat is very local, but then if you're talking about the electricity to the grid, it needs to be really interconnected to work, especially if you're thinking about fully renewable grid. We have as said, fully renewable grid in Iceland, and there we have some struggles. We're a single grid, we are connected, but there are still some difficulties transporting energy between systems, which leads to waste because some of our hydro dams are just spilling water over because we cannot move the energy between sites. So I really believe in interconnectedness and that this is sort of like a joint venture to go into this green future. But for local municipalities taking decision on how to heat or cool your houses for the future, I think that you should always think about sort of like what is your local resources, what can you use? And that I think is very sort of like sustainable for the future. It's sort of like think long term, act now, and the gain is also long term.
So I listened carefully this morning with the panel on geothermal energies, and I heard that some in the room were sighing when it became so obvious that we have potential, but no one is investing. And I find that's the most important point. For the energy transition, the question which companies are actually investing has been key. And in Germany, it was in great parts the old fossil fuel industry that are important in the market, of course. So we discussed this recently at the conference. Who will it be in Germany for geothermal? Does it have to be the government, in parts most likely, but which companies will it be? Which are the investors? Can they be totally new? Is it something that comes from the finance market that is simply organized by finance investment where there's not even a company really behind it? It's a key question for that and also for the future of other energies that we have, and it must be discussed, and I think for geothermal it's not clear, right? That's the key barrier we have, and that we have to solve. How was it in Iceland? Was it totally the government, or was it startup companies that even maybe from researchers that did the first steps?
I think the main source of money came from the government because, of course, local farmers had started to utilize heat. For example, my grandmother and grandfather, they had sort of like a geothermal hot spring very near, so they just took the heat and put it into their house. And imagine in Iceland, which is many times, I will not say always, rather cold and dreary weather, the change in life conditions to have heat in your apartments and a heat source that is sort of like almost abundant. You didn't have to switch it off. So, and of course, my grandparents, they had 11 children, so good heat, many children. So it was a game changer also for our nation, sort of like in living conditions, because living in a damp housing is not good. But I'm totally off track here, but that's okay. That's okay.
And just fantasizing of the 11 kids in the hot sulfur ponds.
Yes. But that was sort of like a game changer for that generation, and now we need to take that knowledge to make the changes for our future. But it was mainly governmental money that went into it, and it was sort of like some part of a fund that realized that not all of the wells that we were drilling were going to pay off. So if it paid off, you will, pay off the loan for a very long time. If it didn't pay off, the small municipality didn't sit up, with a huge debt. So it was the common responsibility of all of us to finance it. And I think that was key to doing that. And for now, to find new finance into these rather risky, because geothermal exploration is always, you have great scientists, but then, you drill the well and it's not always what you thought was down there, but, so you need finance that is rather tolerant and thinking about the long-term gain.
Yeah, and it shouldn't be a matter of money when you look up the numbers. You know that better, right? But it is something in the 200 billion altogether, what I learned for exploration plus the real business case. And if you compare that to other businesses, that is just in the framework of any company's reach. So it is awkward. And then it has to do again with politics and humans when you think about it, that it still doesn't work, even though it is a good business. In theory, could be a good business model. And it was mentioned also by the early panel this morning that it gets confused. The geothermal, the drilling that you need to do gets confused with fracking. And what I find the most disturbing is that we are actually in Germany thinking that way, that not in our backyard, so not on German grounds, not even in the sea, but the gas that we buy is really fracked gas. And that doesn't matter. So to overcome such strange rationales needs a lot of training and education, and then it's too slow because to wait for the next generation, which may have lost this idea, or change, that is another 30 years that we don't have. So I cannot imagine that we get on, except that someone invests in really a lot of communication and marketing of an idea that paves the way for a better future.
Well, and also just social acceptance is a very curious phenomenon, because Landsvirkjun has been building power station for over 65 years. And we just recently did a survey of what the Icelanders think of our how the power station have affected the community, affected Iceland. And over 76% think that our power generation is very beneficial to the community. And because in many of our projects, it has been highly, especially regarding the big dams, highly controversial, and big words have fallen. It's been you're dividing the community and this will never heal. But then we did a survey also for the local people near near our power stations, and the acceptance rate, or that people thought that this power was beneficial for the community, was 78 to 85%. That was for this. And then we asked, do you want, or are you thinking that are you positive towards us going to have more renewable energy? And there we also have a very high acceptance rate. So about 63%, and even a little bit higher if you say new energy just goes into the energy shift, from oil to renewables. So we can see it that the general public is more positive than we expected. And that is, I think, also very important to have in mind.
Yeah. But I guess the benefits, they were at hand, or you could experience the benefits on a relatively short time scale. Because in Germany, I think I give a climate talk almost every week, and very often the question of people is, not the majority, but there's always someone who asks why all the fuss if we are so few people in Germany and we don't matter on the total CO2 emission. And so, of course, for Iceland, you could say that even more.
Try that discussion in Iceland, yes.
So what is your answer if a Icelandic fisherman comes up to you and say, why should I revert to methanol or hydrogen on my ship and do that investment if it doesn't matter compared to all the Chinese fisheries or so?
Well, I think that our government has, with its stating the goal of being without use of fossil fuel in 2040, put some kind of a fire inside the nation as a whole. And I'm not sure if I'm supposed to say this, but being the first to do it was also sort of like we wanted to be the first. So I think we have drawn a little bit of a momentum that we want to be in the forefront of this change. And I think that if we cannot do it, then I think that it will be very, very difficult for other nations to get to that point. So it is a little bit of putting this spirit of, well, Germany, very good in soccer. You know, where do you get that feeling from the nation to strive to be the best in this?
Well, soccer is maybe not the perfect topic in Germany right currently. I was thinking, like, how can a community of the size of the city of Wuppertal can up with a football team which then can beat the English team in the quarters? So, but football topic would be maybe something for lunch or tonight. But I found it very interesting what you also said was about this acceptance rate, because Robert Habeck also said, like, that's one of the big discussions obviously we have in Germany, like all the renewable sources we would be able to have, they face a lot of, like, this NIMBY protest, not in my backyard. Do you experience in Iceland that this and I remember, like, if you take the big aluminium smelters which were located in Iceland, they created a lot of discussions as well. Do you expect such a debate to run differently when it is about, you know, replacing oil imports and getting finally reaching this target? Does it make a difference, or would you then you could also argue, like, when you produce aluminium in Iceland, for example, is a way of exporting your renewable energy and letting others contribute from it. Do you think do you expect that would make a difference for the public opinion, whether you would set up, for example, now a methanol plant for substituting gasoline imports, or is it?
Well, the numbers shows that is not such a big difference, but people believe in that you need new, more clean energy produced in Iceland. And I was just the Confederation of Icelandic Entrepreneurs joined up with the Ministry of finding some solutions or making a roadmap on how to be climate neutral, and we made 332 proposal of how to do that. So I think that you can say that we have joined together in that this is important, and of all the different industries that we're talking in this panel, the renewable energy, we need more renewable energy, was sort of like a word that came up, you know, every 3 or 5 minutes. So it shows us that it's not just important for us, it's important for all the other sectors to change their sort of like path towards a climate neutral future, is that they have the use of more renewable energy. However, we know that when we come into the local community, where we want to have the new power plant, where we have to have the new dam, where we want to have the new windmills, there will be opposition. They will ask, why here, why not somewhere else? This sort of like, I grew up here. So there's a lot of emotional ties. Like Habeck told about the windmills here in Germany. You know, this is not the landscape that you grew up with. But however, I think that for the sort of like the common good, and with good discussion and very open and honest discussions, we will get there, and we will get more acceptance also from the local people. And one thing about that is you need to make sure that the revenues that are being made from making energy, that it sits also with the local communities. You cannot just move all the energy away, and that you cannot have the feeling that there's nothing left behind.
So the windmill debate, I'm following. The windmill debate is, of course, tough because it is about nature also, and bird diversity, and also about tourists. And tourism has become, I think, maybe the biggest business. It goes, I think, beyond fisheries almost, or is equal in pair. And so fisheries that depends on ships with diesel, and tourism that depends on planes with kerosene, they are hard, of course, to get carbon neutral. What's your idea about the flying? That matters to a lot of Germans, actually. Can I fly or not? And the whole debate of fly shame and all whatnot has also not resulted in a very good feeling about the future, though there is potential with biokerosene and other matters that the chemical side of energy needs can also be tackled. And my second question also that has to do with that is, where are you with coupling heat and hydrogen?
Well, well, at least if we talk about international flights, we know that we have an international sort of like obligations, and we want to get to a certain place. However, we know that technologically we are not there yet. Therefore, it is extremely important for a country like Iceland that is basically you need to arrive with flight, that when you come into Iceland, that the infrastructure is green, so that the rental cars that you get will be, you know, using electricity. The buses will use electricity and so forth. So that would sort of like, you will at least do as much as you can for that. I have, just for the last 3 to 5 years, I think that the technological changes in both in flight and also in big vehicles, things that we didn't expect to come so soon, they're happening much faster than we anticipated. But of course, we are also thinking about producing e-fuels. But we know also that we need to, at the same time, produce the energy carrier, you know, where you're going to keep it, and then we need the consumer. So, and this is something that you need to do all at the same time. So it's a difficult task, and I think when you talk about these new systems that you have to set in place in a very short time, then the cooperation is so important. And just this direct dialogue with people, very short connection lines, is extremely important if you want to do this. So that's why it's important that we we use the first names, because in this struggle, you know, we are all brothers and sisters here.
Yeah. What I found very interesting in these two debates, that when you talk in Germany, you have this, then energy consumption is even often perceived as something very negative. I mean, consumption is not the physical right term, but, you know, using energy. While I never experienced this in Iceland. I mean, you have to debate whether, for example, what you said, we would replace fossil fuel, but it is always about, you know, energy is something which, as you said, like you just gave this example. Like, could you imagine what the difference is, like having in the cold weather a heated home, like where the positive effects of energy are always emphasized. And I think when I was teaching energy economics, one of the things I remember is always like the human being can create 1 kilowatt hour a day. That's more or less like the work you can do. And if you look at the final energy consumption in Germany, for example, it's 100 kilowatt hours per capita per day. So basically all the history of our economic development has been of, you know, using more energy and creating value from it. And so by leveraging by factor 100. And but still today, these 80% of these 100 kilowatt hours, 80 kilowatt hours are still fossil in Germany. So there's a huge debate. You're aware of this, like, is this compatible, like migrating to renewable energy sources, while at the same time keeping this economic prosperity, which we gained by using all this abundant, cheap fossil energy. And I found it so interesting that Iceland seemed to be a good example, asking a question in a moment, who could provide a positive narrative that you can combine the two things as well, renewables. But do you think we have to more openly debate this kind of trade-offs between energy uses or prosperity, or is it rather about creating a kind of positive vision as Iceland could provide?
Well, yeah, there's lots of research going into that, and always trying to find out where are simple hacks in which you can be more sufficient or reduce energy consumption. Of course, there are loads of hacks. Our own data show when during the last winter, everyone believed in this idea of energy shortage and black stuff and so on. We are managing altogether 20% gas consumption reduction. A lot of it was carried by industry that stopped producing fertilizer, but also the households saved some 10 to 15, 20% by just cooling the houses more. And by these small social experiments, you understand the linkages between consumption and how far you will go. I mean, sitting in offices and at home at 19 degrees feels uncomfortable, that's it. And it doesn't have to be that way, but it's good to know. We have, of course, giant consumptions in the whole question of storage, cooling, freezing, especially with our food, and that's amazing how the Germans have refrigerators in their homes. I remember the worst ever incentivized program to get to climate-friendly refrigerators was when the state paid for them. For the conversion, and then every family kept their old one and added the new one, and the old one went to the cellar to store even more food at home. And of course we have, and then the energy consumption increased by far with an invested national program. So these crazy things you can look at, and we can study this much better today, simulate it. But one thing is clear, and Robert Habeck said it very clearly, there is no evidence for us spending less energy. You can maybe debate 10% if you are really great with new inventions, or 20%, but you don't get anywhere by just saving energy, and that is the sad news. And also we have this challenge that we shouldn't forget that half of the energy need that we have is chemical. So otherwise it is, we're getting rid of the fertilizer, chemical industry, the steel industry, so it is challenging. But in that, it is not a matter of the technology that is missing, it is not a matter of the business models, it's a matter of the incentivizing of renewable energies and stopping the subvention of fossil energies, which is still full up and running. The funding that we discuss, that we need for investment in new technologies like geothermal, it is all sitting there, but it's currently put into coal and oil and gas. And so if we end subvention, but take care of cheap energy by reverse subvention, then everything will happen. It's really a political, economical discussion, as your minister said, and as you said in the beginning as well.
Well, for us, I think, I know energy saving is also important. I spent most of my career in the environmental field, and then using less is just the first step that you do, because that is sort of like, it should be common sense, but it of course is not. But I think that should always be the first goal. And for us in Iceland, we have had abundance of energy, and maybe not enough care for it. Sort of because we had so much, we didn't really think that we needed to save it. And I think that is just sort of like as inherently wrong, because if there's a value, you should use it well. For us, it's sort of like, if it's too hot inside your house, you will just open a window. You will not, turn down the meter. But this is something that we need to change, and we need to be proud of it. For today, we are a little bit too proud of being wasteful, sort of like letting our houses being too hot or using the water too much and so forth. So we need to change that in our mentality also, to use well and save energy. So for us, that is also important. But I picked up on your quote on an initiative from the government to save energy. And I think it's really also important to talk about these initiatives that failed. Because we are doing lots of projects. Some are a huge success, and we talk about them and we applaud them. Others are not. And I think that we need to also talk about them, because we need to learn from our mistakes. They did it, I think, in Denmark. They gave people incentives to go from for better technology regarding their sort of like heating ovens, sort of like to reduce black carbon. What happened? Well, they just bought more ovens. So, the size of the problem was the same because they just, they had more. So there's a huge need to always think about the core values first, sort of like use less and use wisely.
I think another key learning is, of course, to remember that it is sometimes good to let go of things. Of course, well, Robert is no longer here, but sometimes you have to let go of things if you notice that they would be right. I'm not talking the pumps, I'm talking, for example, tempo limits on our streets. That's the other key German thing, that we want to have free speed on all autobahns, which is of an exceptional extra energy use. It hurts a lot of people. It is dangerous. It also produces huge amounts of plastic particles in the air from the wires and everything. And so the wheels. So why do we do it? It is connected to a deep spirit of freedom, apparently. No one knows why exactly. It's like weapons in the US. You can just burn your idea of becoming president if you touch it too hard. And the same is it with this temperature limit. And so for a politician today, it becomes so important to be advised when is the time to pull it through and bring everyone up against you, and when is it wise not to go into the arena of fighting with everyone, even though you have the full right, it is fully scientifically backed up and socially and health fully backed up, that it would be really wise of us not speeding above 130. But you will not be voted if you stand up for it. And so that is really a hard lesson, to exercise that, to know when do you go and fight as a politician, and when do you give up your beliefs, because you just will lose the people. I find that the hardest, and that's why I have respect for politicians, because they have to decide on these matters almost every day.
Yeah, and I think now with the last 5 minutes we are back to this question of acceptancy and momentum in the society, and I think that it was a good hint, like there are some things which are right, but sometimes just too dangerous to touch. But I mean, given that, well, the initial question was like, how do we recreate the momentum? I mean, I've been in the energy sector now for 20 years. I felt like 10, 15 years ago, there was a huge momentum, like everybody was talking about renewables, and the first windmills were built in Germany, at least. And so there was a kind of, Aufbruchstimmung. Everybody wanted to start doing something. A lot of new startups were coming. It feels like we have somehow lost this momentum, and in many debates, it's more about, oh, this is not working, and this is a challenge, and this is a problem, and maybe we should rather stick to where we are. And maybe a bit like the discussion you mentioned when you were talking about geothermal heating, that people said, well, we know gas and coal heating, maybe that's the one, it's playing safe and stay which we are. And that now, in a moment where many more technology options are available, we should be rather have more opportunities now to do something than less. But still, it somehow feels we are getting less and less traction and less and less momentum. What could be a way, or what's the methods you think we need to more actively push out in order to regain this momentum?
This idea of us is non-factual. So when you look at the progress with renewables in Europe and Germany especially, it has never been that fast now. If you look at the European Fit for 55 Green Deal, the CO2 pricing emission trade, it is the most efficient and ambitious package that we have, and it starts working. And so, and if you see on an international level, even there, when sometimes we are so sad, I just come from the Antarctic Treaty meeting where, again, we couldn't agree to protect the emperor penguin, which is nonsense. But there you also have this impression of us humans failing as a multinational society. But when you look at it, there is even an agreement of China to no longer invest in coal industry outside of China. There is a reduction in their building speed and usage. I mean, so there are things, and India is really India is probably the place where things will be decided in the future, because it's not known how India will behave as a whole. But altogether, at least for Europe and Europe's neighbors, we can say that never ever have we been in such a progressive, transformative spirit. But unfortunately, you always tell us the story of failing, which is sad.
So we need much more optimism. Thank you.
Yeah, I think we have, I think, everybody into the idea of a climate neutral 2050. We know the road ahead to 2040, what is have to be done by 2030. And I think that generally people believe in the future where we are climate neutral, we will have less emissions. I think that the living standard will be even better, but the road there means changing our habits, the way we do it today. And that is, of course, something that is a little bit more difficult to get across. But I think that we need to have having in mind very clear goal for the future, and always talking about this future that we want, and never stop doing that. The problem with knowledge and fact is that people are generally not very moved by it. And as we talked about this morning, you have the greatest paper and you're completely correct, but it doesn't really matter if it's in a drawer. You need to get the information out there, you need to get people behind you, you need to get the decision makers to change their mind. So for me, it's a little bit about that the certainty is hard to get, but you need to change fast. So for us, I think courage is an important theme that we need to discuss, how to take decision without having 100% knowledge. And there we should maybe talk a little bit more together. So because we Icelanders are a little bit famous for the sentence it will sort itself out. You just take a decision and it will probably work. You're more accurate. So I think we should join forces, because both traits are important. You cannot wait for 100% certainty to change. However, you should not always just, it will sort itself out. So a balance is really good.
But I would like to end, if I may, with this, what I started out with. Not far from here in Hamburg is a fantastic exhibition of one of my most favorite photographers, Magnus Axelsson. Maria has brought us together. We have worked together about melting landscapes, the melting cryosphere. And if you time and you look at his pictures of 40 years of people living in ice that are losing everything, you will be touched. And so as a scientist, I've decided I'll put together the data that I have, but also the knowledge of the environment. And it's not so far away. And if you go to Iceland and if you see how you have put a glacier to the cemetery, school kids take tourists and show them what they measure every year, how the glaciers retreat, how the landscape is deserted. We have to say that we know already that some of the fish will no longer be there in the lifetime of the children because the ocean is too warm and acidified. They are moving the fish. And so I would like to encourage everyone who has a question, just go to Iceland and look what we do to nature. Thank you.
Christian, Linda, Antje, thank you very much. That was very much food for thought for me. I think a very positive optimism at the end with Theta Retast. And hopefully in this spirit, the whole day will continue to create these alliances and these cooperations. And thank you very much for your time.
Thank you, Dr. Bote and Antje and Christine Linda. It's been a busy morning, so in order to re-energize, we will now transition to lunch and reconvene again at 10 past 2 in the afternoon. Thank you. Well, ladies and gentlemen, welcome back after what I hope was a nutritious, energizing, and also interesting lunch break. We will dive straight into our next panel so that we can be a bit on time. This is Public-Private Partnerships, How to Accelerate the Geothermal Transition in Germany, moderated by Dr. Andre Deinhardt. Please, the panel would care to take the stage.
August, thank you very much for the introduction of the panel. And we look to this panel a little bit different, or we start this panel a little bit different to the other panels. We start with two keynotes. First, a keynote by Hala Hund Logadottir. I hope it was right. Hala is Director General in the National Energy Authority of Iceland, and Hala earned a Master of Public Administration from Harvard, and prior to that she earned a Master of International Economics from the Fletcher School at Tufts University. And Hala is also the co-founder of the Arctic Initiative at the Harvard Kennedy School, where she now serves as Senior Fellow. Among her other roles, she is a co-founder of Girl for Girls nonprofit, a global mentorship that has the aim to arm young women with courage, vision, and skills needed to take on public leadership. The floor is yours, Hala.
Well, thank you so much, Andre, for this long introduction. And how fantastic it is to be with all of you and have the opportunity to actually dive into some of the important questions that we're all struggling with. You know, how to get from the beginning to the end of our energy transition. I have to start, you mentioned the Arctic. We had a speaker here from the Alfred Wegener Institute just before the lunch. And I have to say, I think it's such an incredible example, the work that Germany has done in the field of Arctic as an inspiration of what you can actually do as a nation. There you have Germany, that is not even a polar nation, that is leading the polar research. Do you know how jealous we are in Iceland? I can just tell you that, you know, we've all been looking at Germany's work in this field, and I listen regularly to stories. I have a cousin that worked on the Polar Stern, that ship that you operated, and she had the coolest job title in history. She was a polar bear guard. Beat that. I'd put that on my LinkedIn, and you know, in a heartbeat. Anyways, but we're not going to talk about Arctic issues directly, even though they're very much related to climate change impacts and so forth. We're here to talk about geothermal. And I was asked to kind of present the key figures, but guess what? You have already heard them. But I'm still going to repeat some parts and maybe just kind of, you know, we have been looking at the fact that Iceland has now 90% of its houses heated with geothermal. We've talked about the fact that, you know, this is a renewable source. This was a transition driven forward during a crisis, as we have now in Europe, during a crisis, an energy crisis that made us take these big steps. I think it's important to keep in mind that geothermal, it's not only about energy security, it's not only about climate change, but it's also a baseload source, right? And when we're now thinking about how to manage our new systems, having access to a baseload sources like geothermal can be an important part of the picture. So I think it's going to be very exciting for us to explore collaboration. As has been mentioned here before, we have completed 85% of our energy transition. That is because of decisions that were made decades ago. And I think that's so important to think about because it shows us how reliable this source is. We depend on it every day and the infrastructure.
that was built during 61 and 83 with our energy fund that has been described here. We still have a path to go, and there I think there is a huge potential when it comes to collaboration as well between Iceland and Germany, because we're looking into areas like offshore wind. And I had these excellent discussions with some colleagues during lunch here. Like, there's so much collaboration potential in areas where we know literally nothing. So we should try to think about strategic ways of collaborating in the energy perspective as whole. All right, so these are the goals that we've covered. But I read this incredible report written, amongst others, by one of my panelists, a co-panelist here this afternoon, about geothermal potential in Germany. If you haven't read this report, please do it this week. It's one of these must-reads because it really summarizes some of the key steps if Germany wants to take on this exciting journey. You know, you've gone to the Arctic, geothermal is pretty closer, you know. It summarizes also areas where we can collaborate. The policy lessons, you know, how it is a political decision, how we need to make sure that the funding is in place. That is a model where we can collaborate. We've gone through that transition. The tech and innovation. There's a lot of things, as we're going to be hearing as well, that has happened in Germany, a lot of lessons already, and some technology that is being developed. And we can collaborate not only on the implementation of the geothermal project with different experts that have been here this morning, but we can also talk about the different offsprings of these transitions. You know, we have carbon recycling. Where is carbon recycling? It's actually bigger than a person, but incredible offspring of this journey. We have Carbfix that is sitting here as well. I'm humanizing all these projects. No, but my point is that we have an opportunity to exchange and collaborate through these innovative projects that have been the output of the geothermal transition. And that leads to the third part here, which is the market. You know, the untold story in geothermal is like was discussed here by so many this morning. It's a communication issue. What is geothermal and what is it not? And it has so often been compared to the levelized cost of electricity. But as we've talked about this morning, the magic of the resource is the fact that you can use the hot water directly, and you can use the different streams from it for different things, you know, cosmetics, fish farming, all kind of things like the companies that I just mentioned here. So talking about how we can think about developing a market, it's something completely different than an electricity market, is an exciting part for us to talk about. And then, you know, knowledge, capacity, and training. It has also been mentioned here this morning. Here we have a long tradition in geothermal. Actually, quite a lot of students come to Iceland from Germany, and a lot of students go to master engineering in this country. But why don't we think about, you know, doing something more in this field? It all often starts with, you know, a young student that learned something and is eager to implement that. And I think we need some of that innovative spirit, because as we will talk about in the panel, the story of geothermal in Iceland is a story of entrepreneurship. And it's a story of successes, it's a story of failures, but it's a story of actually, you know, learning by doing. So, lovely to be with you, and I'm excited to continue the dialogue with co-panelists and learn something as well from our German counterparts, and see all the different ways that we can collaborate together. Thank you.
Thank you very much. Thank you very much for this, impact, for this information. And now the next long introduction for Rolf Bracke. I think it's important to show who is here. It's important because it says something about you and how important it is. And the mentioned document you show us some insights have impact, and you can see it today in the Ministry of Economy. Professor Rolf Bracke is director of the Fraunhofer Institute for Energy and for Geothermal Systems, together with Professor Mario Rockwitz. Rolf previously, as founding director and chairman of the board, established the International Geothermal Center in Bochum as a joint research institute for science and industry. And also he is full professor at the Ruhr University. He holds the chair for geothermal energy systems. The floor is yours, Rolf.
First of all, thank you very much for inviting us and for the organizers to have this great event. I also want to I'll give you some insights about what we have been written down last year in a roadmap on geothermal energy, and some of my colleagues are in this room. Ingo, you mentioned one of the main outcomes this morning when you told us that we would need something like several hundred thousands of people working in this industry if we want to ramp up and if we want to bring geothermal energy from more or less homeopathic uses to industrialized uses. So in order for our friends from Iceland to give you some ideas about the energy system in this country, the total energy demand in Germany is 2,700 terawatt hours per year, and the heating sector is more than 50%, 1,400 terawatt hours. This is 56-something%, and the majority of this heat is needed in metropolitan and urban areas. So there are a lot of towns, of big cities that are thinking about to step into geothermal. We have like 80 cities with more than 100,000 inhabitants. There are 600 small cities and towns with up to between 20,000 and 100,000 people, and 1,600 towns with up to 20,000 people. Imagine, this is a huge potential if we take this as a market. The majority of this urban heat is covered by fossils. We did not make this political investment and decision in 1961 to step into geothermal, but there was a political decision to step into natural gas infrastructure between the 60s and the 80s, and the majority of these cities are served by this source. So the transformation of urban district heating systems with 600 terawatt hours is a major market, and we would need a lot of people in this. The industry sector, another 600 terawatt hours per year. And we'd like to divide that. We had the discussion about high temperature, low temperature in the morning. Our definition is something like 200 degrees C. Above 200 degrees C, combustion processes from hydrogen and from biofuels will be necessary in the future, but below 200 degrees C, geothermal in combination with high temperature heat pump could become a major contributor. I just mentioned the real estate business. There have been a lot of investments into gas infrastructures, and this is a discussion that we are having right now. We also had the call that the geothermal industry needs to be louder. We need to communicate that there is a potential. The conventional gas industry is doing that. I mean, there are a lot of assets in the existing gas infrastructure, especially in the real estate business. So to transfer this requires major political decisions. And there is a fourth aspect which is related to a very special German part of the energy system. This is the old coal mining areas. So in the Ruhr area and Saar area and some parts in southeastern Germany, we are having a lot of subsurface infrastructure which can be used for geothermal by using the water from the coal mines, by using the coal mines as heat sinks and as thermal buffers, as seasonal heat storage systems. So that's the situation that we are facing to. Another situation is this, and the question about how good do we know our subsurface. There have been thousands of deep wells being drilled from the 50s in the last century. The majority from the oil and gas industry, and in high seasons there were like 850,000 meters that have been drilled per year. So we know the subsurface very well in certain parts, in the majority of the parts of Germany. From drilling boreholes between 500 and 5,000 meters well, and Inga mentioned the Geotis project where you get all these information in detail. And you also get the information from the subsurface investigations from 2D and 3D seismic campaigns. And then there is another thing which we also have to address. This is the energy demand in regional areas. And what you will see is we know some areas we know very, very well. We know we have all the information from the subsurface, but there are also areas, especially urban and metropolitan areas, where the E&P industry has not been drilling. So, and where the data are pretty scarce. So this is something which brings the mayors and the decision makers of the small utilities in troubles. Imagine if you're a CEO of a utility that is serving this area or this area, so or in the western part or in the Frankfurt area, so areas where you do not have enough information from subsurface. You are not able to get the money from your bank for a decision. We already heard this in the morning, 20%, up to 20% of failure from boreholes in areas where you do not have enough information from the subsurface. So you won't get the money, you won't get insurance, and you won't get the go from your advisory board to realize such a project. So there is something like a problem that we have to solve politically. And that comes up, or we came out last year, my co-authors and myself, with some recommendations to roll out. There is a potential, which is somehow a bit of a glass bowl in the areas where we have all the boreholes, we are pretty sure. In others, we're not so sure. So we came up with an estimation of 300 terawatt hours or 70 gigawatt hours of demand, plus surface geothermal, so down to 400 meters or a bit deeper, with another 600 terawatt hours, and the huge potential in underground heat storage, not only in the mines, but also in aquifer thermal storage and so on and so forth. And Ingo also mentioned the petrothermal systems, which is subject of major investigations, especially within Helmholtz and others. And this is also a huge potential for the future. So our policymakers should define clear expansion targets. And Mr. Habeck already told this in the morning. We expect to have something like a geothermal summit this year. But we would also need to have regulations. He told us about 2% for wind energy of the total area in Germany. We would also need something like this for geothermal. Then we would need a financial engineering tool. As I said, mayors in small towns or of small utilities, CEOs of small utilities would not get the money from their banks to realize such a project. So a risk mitigation tool like the Nordic Fund and KfW and USAID have been realizing in Latin America or in East Africa would also be a good tool that we would need here, beside exploration and drilling programs. Some key technologies like drilling and reservoir processes, borehole pumps, high temperature heat pumps, and heat storage developments and cross-sector system integration is a topic that's necessary, and we need to look for people who will do this, and the potential is about up to 10 people per megawatt installed capacity. the oil and gas industry should be interested in this subject. I mean, this is a real industry with thousands of people, with a long history, with technology and with know-how, and so geothermal should also make friends with the old fossil colleagues. And of course, we heard already about this broad public relation activity with participatory opportunities on the more local sector. Thank you.
Thank you very much, Rolf. Perhaps we can change the slides back. Yeah, I invite you all to the stage, also Thomas and Thomas. And now a short introduction for Thomas during you come to the stage. Thomas Mar Sigurdsson have 2 degrees in civil engineering and planning from the Cornell University in the US and from Iceland. And he was for more than 16 years in Alcoa industry, and he was appointed CEO of HS Orca in January 2020. And Thomas Jahrfeld is head of geothermal project development at the Stadtwerke Munich, the municipality utilities company of Munich. And I want to start with questions to you, because this is very theoretic, as Rolf said. It's a good plan, I love plans, but you have to fulfill all these wishes. And if I look to Munich, what are the plans for Munich, Thomas?
Before I tell you what the plans are, I tell perhaps first what we do.
Yeah.
The experience now we have in Munich is over 20 years old. We are based in the Molasse Basin in the south of Bavaria, and we utilize geothermal energy a long time now. Sometimes politicians tell us we do research. What we do is real operation since 20 years to supply heat and also to generate electricity from geothermal resources. Referred to Munich, this means we have 6 plants, 3 geothermal plants for heat supply, 3 for electricity generation, and the plants are given by the goals we have. One goal is 2040, the goal for Stadtwerk München to be CO2 neutral. The city of Munich forces us a little bit to be quicker till 2025 to be CO2 neutral, and geothermal will play a decisive role in this transformation. And we will do it on the one hand by the utilization of own geothermal rights, also by cooperations with partners from the industry or municipalities. We will repower our old geothermal sites with to a bigger thermal load. And the third is a little bit research we do. We want for the later for the later years, we want to have a seasonal storage, also to supply on the one hand to store waste heat and supply it in wintertime for peak loads. This is it in general. Of course, we know that this will be difficult to reach the goal 2040, because one project normally lasts between 8 up to 13 years. And if we calculate, we are in today's 2023, we are already in 2036. So the big task is to be quicker, to accelerate, to have easier and simplified methods for procedures and so on.
So it's very interesting and brings me to a question to Thomas from Iceland. How long it takes to install a geothermal plant in Iceland? Because we heard it's a very long process in Germany.
Yeah, well, thank you, and thanks for having us over here. It's been a really informative session today. Of course, it depends on how far you have advanced on your drilling, because traditionally we have not gone fast into implementation of geothermal power, because we want to understand the resource, you want to understand what you have. You can only do so much research on top, so you have to drill and test and so on. So if you take that into account, and then I'm using the experience from the high temperature areas, that can be, you know, somewhere between 5 to 8 years, taking all that into account. But if you have already done the research, I know you have a lot of wells already drilled, I saw that on Rolf's presentation, you have, it shouldn't take you more than 2 years if you know exactly what you have in the ground. And then I'm just speaking as an engineer, no administration process or anything like that.
Of course. Very interesting. And how works it, the collaboration with public partners? Because you're a private company, or
yes,
you represent a private company. How works? How will you collaborate with, for example, with Hala?
Yeah, well, she is basically the energy authority. We get our licenses from her, and they monitor our progress, right, you know, and how we are treating the reservoir, and if we are managing our reservoir and our operations in a sustainable way. But in general, I think the example that's been given many times today about the fact that when Iceland, during the energy crisis in the 1973, we made a leap into geothermal. It was a political decision, and there was basically a fund available by the national government that eliminated a lot of risk for municipalities and private partners. I think that's a model that we can share. I think that worked very well. So for me, that's a good example of how public-private partnership could be involved, because geothermal has sort of reservations and doubts because of the risk associated with finding the resource. Helping to eliminate that risk is going to help everybody to move faster.
Very interesting. Hala, how the permitting works in Iceland? Working? Yes.
Yeah, it's working. Yeah, it's quite a long process, but you need permits for the research phase. Or first, it's actually like a master plan process that the parliament approves. Then you need, or you can have before that permits for the research phase, but then you need permits for the utilization period. And then if you want to produce electricity, you also need permits for that. So there is a strict permitting process. I wouldn't say that national energy authorities are always the most popular party in the energy transition, but we are really focusing on, of course, on making sure that the resources are used in a sustainable way, and that has been critical. You can see, you know, we've been using the same systems for a long time, and will now actually the government has just announced that they will be putting more incentives and investment into the same fund that helped us with the geothermal transition to help us to continue to explore and exploit this extremely valuable resource.
Very interesting. Thank you very much. Today we had a visit from the Minister of Economy and Climate and Energy of Germany, and parallel to our panel, he is in his ministry and speak with the press and explain that we will have in Germany also a risk mitigation fund, that we will have an exploration campaign, and that we want to foster this permitting processes. So it's perhaps something output from this event, I don't know. But as a question to you, Rolf, what do you expect? How long it takes to come really to upscaling geothermal in Germany?
Ooh. Well, if we see the timeline in the installation of LNG terminals in the Baltic Sea, and if political decision makers would see the same for geothermal, then I would be very optimistic. But if I see back to how geothermal projects have been realized politically and in the implementation phase in the past, I'm not so sure. So to my opinion, it's crucial to have this risk mitigation facility in place as soon as possible. And as soon as this is in place, I'm sensing that a lot of local utilities and energy companies will start. So 3 to 5 years.
3 to 5 years. So. Okay, thank you very much. Thomas from Munich. We heard that there is a huge interest, not only from the municipalities in new times, also from the industries. So, for example, from MTU or from BMW. There are some projects planned between Stadtwerke Munich and BMW or other big players.
Yes, generally speaking, companies are one of our clients which want heat for their consumption. BMW is only an example in this case, of course. But they of course now also have CO2 goals which have to be fulfilled, and additionally one decisive point has been not so recognized before. This is the consequence of the energy crisis, because now communities as well don't want to rely on gas no more. And if they have a domestic resource, of course they would like to use it. Stadtwerke München as well. We have a totally new speed in our decisions after evaluating geothermal energy as a energy that is secure, that is available. And before, 1 year ago, we have some new plants, gas-fired plants in Munich. We concentrated on that. Geothermal was nice to have, but now it has a really decisive role. And 400 megawatt thermal have to be substituted by geothermal energy now, and this has to be accelerated now.
Thank you very much.
And concerning, sorry, Andre, and concerning companies, they really are interested now. We can offer them, or we could offer them more flexibility also in their supply, because on the one hand they can use the heat for their production, and the rest can be supplied into the local network for district heating.
Yeah, very, very interesting. And I have the feeling that we are in, I don't know if it's too big, but it's a new age for geothermal energy in Germany. It starts now, perhaps here. So I have a question, because this new age is passed in Iceland, more or less, regarding the cascading. We spoke together in advance, and you mentioned that this cascading of the use of geothermal is very interesting, also not only for your company, also for all the partners. Can you explain it, how it works?
Yes, happy to do so. I think the cascading uses of geothermal energy is a great example of how the circular economy should work. When you extract the fluid from 2.5 or 2 kilometers below the ground, it comes up as steam and brine, and the brine is used, of course, in heating, but it's also, in our case, used in one of the most popular tourist attractions in Iceland, which is the Blue Lagoon. It's so rich of silica that has been both used, for healthcare products, for cosmetics, and as well as a popular tourist place. Another example of cascading uses at the same location is CRI, Carbon Recycling International. They set up a research facility and then an operation where they were using our steam, electricity, hot and cold water and steam from the power plant to produce methanol, green methanol. And then the third example is that in one of our other power stations we use lava-filtered seawater, basically drill into the lava to get seawater to cool the turbines. That gives us 6,000 liters a second of 38 degrees hot sea. And there's a aquaculture farm that's producing fish, you know, and we have another company coming in investing $450 million using that seawater to produce land-based salmon. So those are the type of cascading uses that we see in our case.
Wow, it sounds like a science fiction film. Cool. And yeah, if you have such projects, every time you need money, of course, we all want to invest. Do you think it helps to be public-private or private with public in with public shareholders to finance such projects?
Yes, absolutely, because it's about the risk, and if you have this this public-private partnership, that unfortunately, but history tells us that the private partners are usually better at handling risks that are such as construction risks and other risks. But you have the guarantee and the offtake of the public companies, and that combination has turned out to be very successful in multiple cases in infrastructure, and I think this could be the case here as well.
Yeah, very interesting. We're coming slowly to the end, and I will look to this to the topic, public-private partnership, how to accelerate. I think the most important part is how to accelerate geothermal transition in Germany. And I want to know from every one of you one point which you mean that is key to accelerate. I know it's not simple, but I want to start with Rolf.
I would say upstream. So one word, upstream. Portfolio management in upstream. So bring the 1,000 utilities together, the smaller utilities, and make a portfolio and start a risk management on that.
Okay. So, can I ask something to this statement? Yeah. Do you think this construct have to be part private and part public, or mostly public?
Well, in the very beginning, I believe that a more public institution would prepare the ground. So a national geothermal development company that is selling the boreholes to the different utilities would help a lot, I believe. I mean, we learned this from other countries. Plus, if we look to the large urban areas, so the Ruhr metropolitan area where I come from, 8 million people, 50 smaller and larger cities together, all of them are looking towards geothermal now, and none of them will be able to develop such a nice department like Stadtwerke München have been doing with 20 or 30 people. So join forces and develop your own business together with the portfolio in a larger area in order to share the risk. This is something which I would see. So first of all, prepare the market from the national side with perhaps with a national, either with the exploration campaign or with the national development company, plus starting a portfolio management in the upstream area with a lot of smaller companies coming together.
Thank you very much. Hola.
Yeah, the one big word. So I would maybe just kind of continue a bit where you left off to begin with and say that in Iceland, the district heating system, there's like a concession that is allocated to a municipality, and the concessions for the urban areas have to be majority owned by the municipality. So that's the public-private partnership kind of element in that story. But my word is seeing is believing. It's a sentence, actually. But I think if you look at Iceland's story, you know, it wasn't like the plan of doing everything like this. There was the first drilling in Reykjavik in the early 1900s, and it was used to heat a hospital, actually our national hospital, and used to heat like a public school. And then people started to say, okay, wow, this actually works. And then, you know, slowly by project by project, this journey that we tell the story of here today, you know, it happened through these steps. So I think it's actually very exciting to hear about your next steps, given the fact that, you know, it seems that you have done something successful and you have the opportunity to, you know, now use that case to scale. But definitely in Iceland, you know, the municipality that was successful made the neighboring community jealous. So they had to do the same. So it's seeing is believing.
Yeah, I think in Germany it works on the same way. There is Erwin Knappek, it is the mayor of Unterhaching, and he was the first in the Munich area, outside of Munich, and all the others think, oh, why it works in Unterhaching? I want also this way. Erwin. Okay.
Yeah, only one point is really difficult, but to come to your point, of course it is visibility to show what we do, to have public attention, but of course, like Rolf said, we are working on a portfolio. Actually, we have a break, we do nothing. We don't have a site where we drill, but we will start with all projects at the same time then. And this means that we develop patterns, how we can simplify processes internally and externally. That means also, Minister Habeck was here, that we need a framework that enables us to work quicker. We have a very complex legislation in Germany. We have long bidding procedures, and simplifying this, if we simplify this, we would win 2 or 3 years, I would say. And this would help us because it is the one half of another new project. So this is what I would wish if I could influence it.
You can. You
yes.
are in.
I work on.
He is in the board of the German Geothermal Association, so he speaks from time to the minister. Thomas.
Well, I think you should try to create a win-win platform. Identify a community, and my friend here next to me is probably the one, where you know the probability of success is high. Implement faster, implement well, and then you will save gas, which is good for your industry and good for the climate. So create a win-win platform.
Thank you very much. I have to look to August. August, show me the numbers. We have 4 minutes left. Right? We can consider to watch a movie. Someone want to watch? No. Do we have? We have a movie. We have a movie. Not Bluespotters, no. Or do you have questions to the panel? No questions. We can watch the movie. I like this movie really very much. So before I want to say thank you very much for the long journey and for the time in the panel.
Über die Hälfte unseres gesamten Energiebedarfs in Deutschland ist Heizenergie. Geothermie sieht man nicht und deswegen denkt man nicht an sie. Aber man kann, wenn man so nach vorne mal schaut und das Potenzial von geothermischer Energie im Untergrund sich anschaut, können wir über 40% des zukünftigen Wärmebedarfs durch geothermische Energie abdecken.
Ich kann mittlerweile mit dem System der Erdwärmepumpe aus 1 Kilowattstunde elektrischer Energie 4, teilweise 5 Kilowattstunden Wärmeenergie erzeugen. Und von daher ist es eine sehr, sehr saubere und eine sehr effiziente Energie. Seit ungefähr einem Jahr schießt die Nachfrage von erneuerbaren Heizungssystemen durch die Decke.
Wenn ich mir überlege, welche wunderbare Möglichkeiten wir haben, den Untergrund und die dort verfügbare Energie effizient dafür zu nutzen, Gebäude zu heizen, zu klimatisieren, dann ist das einfach eine unerschöpfliche Energiequelle, die es gilt in Zukunft anzuzapfen.
Da schenkt uns die Erde Energie für viele Generationen umsonst. Das ist ein so großartiges Potenzial, dass wir verrückt sind, wenn wir dieses Potenzial nicht heben, wenn wir dieses Potenzial nicht nutzen. Wenn ein Land wie Deutschland, hochtechnologisch ausgerüstet, ein reiches Land, das nicht schafft, wer denn sonst?
Ich würde mir wünschen, dass die Geothermie flächendeckend in Deutschland als die dritte Säule der Energiewende anerkannt wird, dass sie den gleichen Stellenwert bekommt wie die anderen beiden, Wind und Solar. Und letztendlich, dass man die Verfahren, um Geothermie zu erschließen, so erleichtert, dass es wirklich zum Selbstläufer werden kann.
Around the world, countries are looking for greener alternatives to fulfill their climate commitments and reach energy independence. House heating accounts for 40% of global CO2 emissions. We must reduce heating emissions to reach our goals. In Iceland, where 90% of heating is geothermal, we save 3.7 million tons of CO2 annually compared to oil heating. That's nearly 11 tons saved per person every year. Geothermal resources are available all over the world. Even low-temperature areas are useful for district heating. Icelanders have been using geothermal energy for 100 years. We have the expertise and experience to help you reach your goals. Let us help you give back to the environment. Green by Iceland.
Okay, that was a very fitting segue into our third panel on harnessing geothermal energy potential and its cascading uses. And I would like to invite Birta Kristín Helgadóttir, the moderator, and her panel. Please take the stage and let's give them a warm welcome.
Thank you. You can all hear me now. Great. Thank you very much. Hi. Take your places, please. Dear guests, thank you for a great day already and so far. What a day, and what informative discussions and lectures that we've had here. And I can assure you that we're going to continue on that path here on this panel that I have with me, where we're going to cover this topic, harnessing geothermal energy potential and its cascading uses. So we're going to dive a little bit deeper into the cascading uses that they briefly touched on in our earlier panel. But I wanted to maybe just start our panel with giving my panelists the opportunity to present themselves, where you come from, and maybe your entry into the geothermal sector. So if we just start with Eiríkur.
Hello everybody, nice to be here in Berlin. My name is Eiríkur Bragason. I'm the COO of Arctic Green Energy. My background is actually I studied here in Berlin at the TU Berlin, ingenieurbouwwerken. But I've been working on geothermal projects more or less all my life in Iceland, in Indonesia, Philippines, China, many European countries. Today Arctic Green is operating many hundred heat pumps. We have drilled close to 1,000 deep geothermal wells, and we are producing 4.2 gigawatt of clean energy. We have contracts with 74 cities in providing them with heat, and we see great potential here in Germany.
Thank you. Harpa.
Yeah. Hi to everyone. My name is Harpa Pétursdóttir. I have the longest title in the world. I am the Director of Stakeholder Affairs and Administration. Very long and tedious, but it's a fun job, I promise. I'm here on behalf of OnPower, which is the second largest power producer in Iceland, after the National Power Company, but the largest geothermal producer in Iceland, with 428 megawatts installed capacity. We produce 550 megawatts thermal, so we are quite large in that sense. Our main focus is on producing electricity and hot water for district heating, but our focus is moving a little bit more towards innovation and the circular thinking, the cascaded use of the resource. We do have a business park, which is a green park around our power plant, which I would tell you a little bit more about later. But yes, I have to say it. We have decided that we will have the first geothermal power plant which is carbon neutral, which will be Hellisheiði power plant by 2025. We are really proud of that, even though it's not happened, but we intend to reach that goal. Yes, that's me.
Thank you. Exciting. Marit, please.
Oh, okay. Hello, good afternoon, everyone. And I must say I am incredibly honored to be here as a non-Icelandic and non-German person. So thank you for inviting me as a Dutch on your fantastic summit. I see a fellow Dutchman there, yeah. So my name is Marit Brommer, and my official title is CEO of the International Geothermal Association. But I guess my real job is being a geothermal diplomat. I travel the world. Yes, for fun. I do that quite out of passion as well. But also to whisper in the ears of upcoming economies about the beauty, about the value proposition, about the technology of geothermal. That we are unknown, especially in the global south, in the developing world, it's a fact. Unless you happen to live on a volcanic island. And Icelanders have helped to develop those. At the same time, I really see the benefit of geothermal coming more and more to Europe. Now, we are not that active yet in Europe because we have many sister organizations such as the German Geothermal Association, and of course in Europe there is AGEC. And at the same time, through our travels and through our, let's say, diplomatic work that we do as the International Industry Association, we happen to be at the UN, we happen to be working with the World Bank, we are in IRENA, I'm sitting in the board as well of IRENA, the International Renewable Energy Agency. And there is such a huge need to lobby and to promote and to make geothermal visible. We are unknown to the world, we are considered as dwarfs, we have 0.05% in terms of installed capacity for electricity, and 0.4 when it comes down to renewable heat. Wind will surpass 1 terawatt by the end of this year, and it's celebrating 1 terawatt of electrical installed capacity, and we have 16.4 gigawatt. We have a job to do. I'm delighted to be here because I think exchanging knowledge and doing this technology transfer, not just in Europe, not just between two bilateral agreements in countries, but all over the world, and speaking about the benefits, the value, the solutions that we bring, and not just speaking about all the difficulties and the challenges and the risks, is, I think, a major task. But with you, we can do it. Thank you.
Exactly. Thank you. Þorleikur.
Yeah. I say the same. Good afternoon to everybody here, and thank you for having me. My name is Þorleikur Jóhannesson. It's a very old Norwegian name, we can say it, or Icelandic name. I will put the burden on you saying that or pronouncing that. I'm a mechanical engineer. I act as a marketing manager for the geothermal division of Verkís. Embassies is one of the largest engineering companies in Iceland, and we have been there, for more than 90 years now, and we have been participating in all the renewable projects in Iceland, so to speak, both all the hydro plants and all the geothermal plant as well as on the district heating system that are all over the country. We have also worked abroad. Me, myself, I have worked, for instance, for Eiríkur, and I have been active in Kenya and Indonesia and other countries. I started very slowly in 1990 in geothermal, designing snow melting system, and then I moved to district heating, and then up to power sector. So I took the enthalpy on the wrong way. I decided to start slowly, and now I'm working more and more on power generation from geothermal.
Great, thank you. And I of course forgot to present myself. My name is Birta Kristín, and I'm the Director of Energy at Ebla Engineering, another engineering company in Iceland. In this panel we're going to maybe be focusing on Europe and Germany, as we've been doing today, with know-how and experience from Iceland. So I wanted to ask start with a question, because we've gone through what is low temperature, for example. We started the day about hearing from that, and we define that in not the same way always. So therefore we wanted to maybe just ask the panelists, what is cascading use to you? Because that can also be not misinterpreted, but interpreted in various ways. So let's just start with Eiríkur.
Yeah, well, I think Thomas More described it very well here earlier. Our ideal case is the power plant in Reykjanes, where they are using the steam for steam production, for electricity production, and then they take it to the district heating system, and then they use it for carbon recycling and now fish farming. So that is a very good example. So we at Arctic Green, we are working in cooperation with a utility company of Budapest in Hungary, and we are also working on a power plant just outside of Budapest. And the plan is to use the heat that will be approximately 120 degrees for producing electricity. And then we will use the outflow of the power plant for heating some buildings in the village. And then we will use also the outflow of the power plant to heat greenhouses. One big company that is growing tomatoes will build a greenhouse close to the power plant, and this and the remaining heat, the plan is to use that also for swimming pool. So this will mean that we will have 4 revenue streams, which is makes our business case fly, and this is very important. This is the main reason why we go for cascading use. But this project also has many positive sides. This will obviously provide green electricity, green energy to the Hungarian grid, and so with lower their import of gas, make them more independent in energy. This will also reduce the pollution in the city and improve the health of the public. And by producing tomatoes in wintertime, then they are less depending on importing tomatoes from Turkey. I have nothing against Turkey, but it makes them more independent in food production.
Very good. And maybe Harpa, if you also touch on the cascaded use and just add add on to that maybe on ON's business model as well.
So we have this power plant, Helleshus, which I would say is an ideal case of how you can put the cascaded use forward and benefit from it. Of course, another ideal park is the one that Thomas von Iceland told us earlier from the resource park in Reykjanes. It's the same concept. It's the concept of taking the resource and exploiting it down to the very drop to get all the power that is possible from it and use it for various production and different facilities. Our business case is, it's the same case. It revolves around taking at least 2 value streams from the power plant and making something in a more sustainable manner than if it weren't there. So we're trying to use it for the benefits of everyone that is participating in this green business park, which our geothermal park is. So we take brine and steam up from the ground at around 200 to 240 degrees. We produce electricity, hot water for district heating. We then use the brine and electricity at night when there is low demand and produce green hydrogen, which we have been doing for 2 years now. Afterwards, at a lower temperature, we use it for different customers that we have based around our power plant. And then, we also use the power plant itself as a geothermal exhibition, which is a tourist attraction, where we have around 100,000 people visiting each year, mainly tourists. So, in my opinion, the possibilities are endless. And I think that we haven't even imagined everything that we can, everything that we can do in the future. I think with technologies and innovation, this will be a fantastic business case.
Mm-hmm. Very good. Marit, care to add to that?
Yes, I can. In the sense that, as a disclaimer, I don't know anything about geothermal myself, having never worked in geothermal. So all I say is based on what I see and what I observe and what people are telling me. In the sense that I'm a geologist, 20 years oil and gas, okay? That's my forte. That's what I do know well. And I see the similarities in geothermal because this is a resource industry. We are not just an industry that is producing electricity or serves heating and cooling. We are a resource industry, very similar to the oil and gas industry, and maybe not so much gas, but certainly oil. So think of geothermal, in my opinion, is to think about it as an asset that is delivering multiple values and multiple solutions to multiple people and customers. And hence the work that we do at IGA, together with all our organizations in renewable, is vouching for the Sustainable Development Goals. So we have 17 of those. And actually, without any pride, of course, but yes, we are very proud. We are the only renewable technology that covers all of the 17 SDGs. We are not just serving SDG 7 when it's about clean and affordable energy, because we do that really, really well with geothermal. So does solar and so does wind. But actually we provide jobs, we create economic growth, we serve for equality. We have in the cascading use in El Salvador, women are put to work because of geothermal. And I guess it's all these things that makes geothermal not only the most beautiful resource that we have on our planet, but also a very strong business case. A very strong business case. And that's the point I would really like to make at all these UN high-level agendas, that this is a solid business case for investment. Over to you.
Great, thank you. I can see you're very passionate about geothermal, and it would be great to hear from you, Þorleikur.
Just a few words.
Yeah.
Most of it has been mentioned here, how we can use the highest part of the temperatures coming from the ground-produced electricity. Then the outflow can be used for some industrial process, and the outflow from that can be used on district heating processes, and then swimming pools, and then finally fish farming, and at the end of the line is probably snow melting before we can re-inject the water again. But I like to think about cascading use of geothermal water and looking at the district heating in particular, because it was mentioned here, you say Germans don't have more than 50, 60 degrees. Never mind, what you find is what you have and what you have to use. So I like to think about this cascading use of of water from geothermal wells. We know them, they are very expensive, and we need to squeeze out every temperature. Sorry, my wording is probably not correct. Every temperature we can before we re-inject it maybe at 10 degrees. First, when the heating system starts, we can use the heat directly in a heat exchanger. The outflow can then, when the heating power is increased, we can couple heat pumps to it. And further, even the third or the fourth, until we have squeezed all the last remaining temperature elements of the fluid and put it into the district heating. This is exactly that we have been doing with Eiríkur and his company in China, where they find water of 40, 50 degrees Celsius, and by doing this in a serial manner on the primary side of the geothermal utilization, they managed to heat 100,000 of square meters with temperatures that are much colder than the coffee of McDonald's.
Great, thank you. That's an interesting point, and coming to the district heating aspect of this, you two, Arctic Green and Varkis, are obviously very experienced in that and on power as well. I don't know if this is a volatile question. I'm still going to ask it because it was discussed earlier today, and it was brought up. Why isn't Germany doing this? I know we didn't prepare for this question, and I'm going to just shoot this over to Marit to start. Maybe just why isn't Germany doing this? Why is geothermal important for Europe and its energy transition? So you can also take this from a European perspective.
Yes, it's my non-German and non-Icelandic entity. Yes, well, thanks. Yeah. Well, look, I think I'm now 5 years in this job, and I really see things are moving. So to really be fair to the Germans and also to the Dutch, because I see the same thing is happening in the Netherlands, slowly but steadily, geothermal is being mapped into their respective country's jurisdiction. So it's not that there is a standstill or there's nothing happening. I guess the real point of the previous panel discussion, and I really liked all the points that the panelists were making, is about acceleration. You know, you want to see growth. You don't want to see individual projects happening. You want to see a portfolio. You want to see a massive investment case for multiple wells to be drilled simultaneously and learn from that, because that's how oil and gas works as well. And the reason why, and I think, Artni, it was you this morning who spoke about political will. And let's be honest, I mean, it was fantastic to have Minister Habeck here. And at the same time, and I know this is very volatile, but I can do this as a non-German and a non-Icelandic point, but I don't think there was a real strong political will to say yes to geothermal. There was strong political will to say yes, climate action. And look at solar and wind and geothermal, of course, it's part of it. But really that vouching for and that sort of strong political statements that everyone in the constituency can adhere to, comply with, and say, okay, well, if he says so or if she says so, then I'm going to commit to it. I think that is what is, in a way, in the 27 member states, not just Germany, but in the 27 member states still missing. And that is not just Germany, that is the EU. And if I then go back to the EU, I also have quite some good relations, of course, in Brussels. I mean, even our fellow countryman who is the chair of the Fit for 55 package, I mean, Frans Timmermans, I mean, he's the one who can potentially roll out geothermal. It is not mentioned once in the packages. And that is, of course, partly to do with us as lobby groups, because let's be honest, we're not doing a good enough job to lobby, to promote, to visibility and all this. And that has to do with money, because this is not an industry that is yet willing to put skin in the game for lobby. There was recently a clean coal campaign. $300 million was put in a campaign to promote clean coal. 300 million, clean coal. And now all of a sudden coal is back on the agenda. And that's how it works. And we don't have that in geothermal. We're scratching the pennies in order to make beautiful movies. I mean, there is no discredit to anything that has been done and is being put in place for promoting geothermal. It's all very lovely. But ultimately, we don't have the hundreds of millions to put political will backed up by industry investment on the agenda. And until we do that, I think we remain a lovely industry with a fantastic, let's say, track record in building good projects, but not the growth that we are anticipating in this panel. Thank you.
Maybe Þorleikur, you can start by. Yeah.
Yes, one of the nicest way of utilizing geothermal energy or geothermal heat is to use it in district heating system. We know in Germany, if you talk about hurdles here, in Germany, I hope you may correct me, Rolf, if I'm wrong, about 50% of homes are heated with gas on individual homeowners level, 20% with oil also on homeowners level, only 20% or something like that with district heating system, either powered directly by some burning of some, maybe biomass or fossil fuel, and some of them get their heat from combined heat and power plants. So maybe that is the problem. I mean, I think that from what I have read, that I hope that district heating will become a trend in Europe and also in Germany. We have to, I mean, I have read that maybe 50% is doable without some very, very big or complicated effort. So I see the way people are heating their homes now is the main hurdles for developing. And when we build those district heating systems in the future and we connect new houses, maybe I will come to that later, that the housing indoor heating systems must be correctly designed to be able to get the most from this low temperature resource. Heating houses, heating ambient air 20 degrees with temperatures over 100 degrees is ridiculous, and we can talk about that probably a little bit later.
Yeah. Thank you. Do you want to add to that, Harpa?
Just add, I am not an engineer, unfortunately, but I think, in my opinion, geothermal, it has to be a part of the solution. I think if we want to reach our goals, our climate goals, which are very ambitious, we need to focus on lobbying, we need to focus on policies, governmental initiatives to further the development of geothermal in Europe. It's right, Marit, I agree with you that, I mean, 10 years ago, talking about geothermal in an international context, people were like, yeah, great. It's fine for you in Iceland and Japan and Italy and Turkey, but in general, in Europe, this is not a feasible possibility. But I think with innovation and technology, we are seeing that, yes, there are still possibilities that I think, and we are responsible to try and utilize.
If I may comment, I've been attending geothermal conferences in Germany more or less in the last 15 years. And so far, it has always been focused on geothermal power production. But there was a very clear change 1 year ago after COVID. It is now all about geothermal heating. So in my view, Germany is on the right track. Obviously, we all are the view that you could and should go a little bit faster. I think part of the issues is related to drilling risks, and it's my view, personal view, that you are over-dramatizing a little bit the risk of drilling. Drilling a deep geothermal well in area close to Munich, directional well will cost probably 12 million euros. That's a lot of money. But drilling a vertical well in a well-known area that is only 3,000 meters or 2,500 is only 4 million and is much less risky. And it is not only because of the drilling process, but there are also all kinds of new technical solutions that are available if the well is not producing in line with what was estimated, mentioning heat pumps and stronger pumps and using the well for injection instead of production, etc., etc.
Great, thank you. It looked like you wanted to add something, but I'm going to shoot in a question first and then give the word to you, Þorleikur, because we're talking about the wells now and the practicalities of starting a project, I'd say. Could you maybe comment on a successful planning of a geothermal district heating system or a project in general?
Yes, maybe. The district heating, okay, the geothermal resource, the district heating system and the house heating system, they have to talk to each other. So it is very important that you, depending on the temperatures you are expecting to get, that the in-house heating systems are designed accordingly. I know all this, it's possible to bring lower temperature up to higher temperature via heat pumps and so on, but it is better to be able to live without it mostly. So I talked about heat pumps earlier, but that is indifferent. That is for squeezing out the last remaining temperature before re-injecting. So I say no chain is stronger than the weakest link, and I have often seen in my project that the in-house heating system, I mean, this is the case as it was in China. They just designed their heating system like the Soviet did, you know, with small radiators and so on, and okay, poorly insulated houses. And it wasn't until they designed it to have floor heating systems on every floor, so the temperature from the heat plant, so to speak, into the system no more than 35 degrees. And imagine all the how opening this was for all the resources you could find. You were often playing with 50, 60, 70 degrees. Before that happened, you know, those resources they were, you know, doomed, you know, unsuccessful. But by having the system designed and engineered in a proper manner, that I think is one of the keys. But there are, of course, many others.
Of course. Would you like to add to that, maybe, Eiríkur, because you've been working on several projects now in Europe, and Thorleikur was actually referring to projects further away, but still something that you've also been involved in China. You've been there designing systems and projects. You've also been here in Europe, in Budapest, like you mentioned earlier, Slovakia, Hungary. How do you see the market developing in the past, and how do you maybe foresee the future?
Well, I think there is a tailor-made solution for every city. I would like to use the Budapest city one more time as an example. The city administration decided that a new urban area in Budapest should only be heated with geothermal. So no other solution was allowed there. And this speeds up the process, obviously. Another decision that was made was to split the heating periods. So the systems are not operating at the same temperature all the year. In winter time, obviously, the temperature in the system is very high. But in summertime, there is also a lot of heat use in summertime. People go to take a hot shower, wash their hands, and there are also laundries and industries using hot water. And in that period, you can lower the temperature and speed up the use of green energy. Yep.
Great. Thank you for that. And since, I mean, the actions that you're mentioning, they're on the administrative level, I guess. They're coming from the municipalities and partly, right? So I wanted to maybe move over to Marit, because you come from the Geothermal Association, where your goal is to support the sector and deliver the future of clean energy, etc. You collaborate with all kinds of organizations and agencies, and we cannot maybe talk about geothermal without mentioning tariffs, policies, the development of feasibility economically, but also environmentally. So I'd like maybe if you can comment on that, how you see this developing, how it has been in the past and the future.
Yeah, sure. Yeah, no, I think it's, I mean, it goes without saying, political will goes together with the right set of policies. I mean, ultimately, someone can shout yes to geothermal, but if there is no regulatory and hence legal and all kinds of supportive incentives as a framework in the jurisdictions that you want to develop geothermal, it is a loose sand of it's a bag of loose sand. So, in that sense, what we've seen all over the world, and again, this is, I mean, we have a couple of countries where electricity is already being developed through geothermal, with either the help of Icelanders or the New Zealanders, or a combination between those countries. We have Japan, Indonesia, the Philippines, and you see that that has always been a, let's say, a combination between the right political mindset, the right, let's say, help when it comes down to the legal and hence the setting of the tariffs, in combination with good resource exploration, but also management, because ultimately this is a resource industry. The resource needs to be managed, and hence the framework is more than just allowing geothermal to happen in a specific jurisdiction. It is also about understanding that you're in it for a long term. It's a long-term vision that most of the governments have set, let's say 20, 30, 40 years ago, very similar to the Icelandic story. And at the same time, I guess what you see with heating and cooling, it's a different beast to tackle. And hence, electricity is either it's a regulated market or it's an unregulated market, and hence it becomes a government decision how to deal with the electricity pricing and tariffs and incentives and what have you. But heat, as a unit, as a joule, as an energy unit, it is not easy to manage, not even within the country, but also within Europe. Hence, the discussion is, of course, and I was speaking to Rolf about this as well, the strong gas lobby. Because I come as well from a country where there is a strong gas lobby, whether or not it is a domestic gas lobby or a foreign gas lobby, there is a gas lobby because our infrastructure is based on gas. Gas is a market, it's a spot price, it's a volatility that is built in economics for governments, for industry, for the citizens, for consumers. And to change that and to appreciate that we have either a public-private partnership to make or a public that needs to step in and take control of the utility, it is all to do with the economics of the resource. And hence tariffs and tariff setting and understanding what the levelized cost of heat is going to be the major breakthrough for not only to compare and compete, if we are speaking about competing with our gas friends, but it is also about understanding that we are indeed in the long run more affordable. But the fact that you can win so much money with gas based on speculation and based on volatility and all kinds of external factors, it's a total different business case than building on tariffs and says, I'm going to pay you 25 euros the kilojoule for the coming 25 years. Because that's the game, ultimately, that you want to go through with geothermal. And I guess this is the real pain point in many discussions, and I'm very interested to find out how the German government is going to deal with this, because the Dutch are losing it at the moment, because we are still fixated on gas pricing. And hence gas is the only, at the moment, competitor to in heat at least, to geothermal, because there is no alternative. Yes, of course, people will say green hydrogen coming from Colombia, but that's 25 years from now. So at the moment, it's gas versus geothermal in heating and cooling, and basically heating in Europe. And that's an interesting discussion, I think, in general in the EU.
Yes. Do you like to add something to that?
I just wanted to maybe reiterate what Árni was saying this morning about the importance of the state participation. Just the mere fact that we did have an energy fund in the early days made totally all the difference. This made the business case so that it was not a crazy idea to go ahead and drill a hole, because the risk was mitigated in such a way that if it was a failure, you didn't have to sit up with the cost. And I think this is a political decision that the governments need to make. Are we going to have gas and geothermal compete on prices, which is very hard at this moment? Or are we thinking long-term? Investing in it and seeing the country saving in emissions of greenhouse gases rather than cents.
Yeah, exactly. And yeah, please,
one point,
please do.
Maybe Halla could explain this a little bit better. But in the old days, when we were planning district heating systems, there was, to be able to calculate feasibility into the district heating system or the operation of the district heating system, everybody must connect. in the area. Everybody had to connect, and you were not allowed to use anything else. Am I correct? This was in some regulations of some district heating company, and that was very important thing. I don't know if this is doable in modern times, but this was actually very good. Another thing, it doesn't matter if it is public or municipally based operated system, and then the pricing, of course, then has to be regulated, because if everybody must connect, you have a monopoly and you cannot play with the price. So that has to be regulated as well. And we have some mechanism in our laws how we deal with this, and maybe Germany can learn a little bit from us in that respect.
Definitely, or probably, I guess. But Eiríkur, you, I mean, because you mentioned previously that in your projects there have been rules about this. You can only add geothermal. Can you comment maybe a little bit?
Yeah, well, one of the, I forgot to mention one of the side effects of our project in Budapest, which is obviously the price of heating will go down. The heating prices today are simply so high that our project will reduce the cost of heating in the households by close to 55%. So we take the risk of the drilling. We with our engineers, we evaluate the area and the best drilling locations, and we take a risk and execute. And we fund the project completely, but the city has the option to buy half of the heating plant when it goes into operation. I think that's a very good compromise, because it's very good to have the local authority involved, or the local municipalities, because in the end we are always using the natural resources of the people of Germany or Hungary or whatever.
Great, thank you. Since we've gone into this financing part of our huge project ahead, utilizing geothermal better in Europe, I maybe want to ask a question in that regard. We heard from the fireside chat earlier, you raised the question, which companies are driving the change, which companies, or who should be the one financing? That was a question raised. It's definitely difficult to answer it, at least entirely today, but I'd still like to ask the panel, who do we need to drive this change, and what do we need to drive this change? Because what you've been describing now is that the situation in Europe and Germany is kind of a mix, but mainly private companies investing and then dragging the public authorities in. So, yeah, Eiríkur, if you start.
Sorry, I continue talking. I think the utility companies are the clear candidate for taking the lead in this. And they only have to, take the risk during the construction phase, because when the heating plant goes into operation, you can leverage this up to the roof, up to 80% or so. So, and you can recycle the funds and start a new project. Yeah. So it's not so complicated.
No, not so complicated. But do you want to add maybe to that, Marit, if we start with you?
Well, I would say it's my former friends from the oil and gas industry that are needed. And yes, Eiríkur, I agree, it's utility companies, but most utility companies at this stage, they have a risk profile that is not suitable for subsurface. And hence, the reason why wind and solar is much more effective, because they have a very low risk profile and it suits the utility companies very well. But subsurface is more difficult. It requires clever people who understand what a reservoir is and how to utilize it and how to manage it and how to operate it, etc. That's a risky business in a way, which can be completely mitigated because of smart people. But I would vouch for the oil and gas industry, and that is not because I am a lobbyist for the oil and gas industry here, but it is the only one with cash in hand, is the only one who is making at the moment huge profits. Shell never made any more profit than last year, which is ridiculous if you think about it. 100 years at service, and they make the most huge profits end of 2022, which is insane. And I would say, and I would argue, the only industry that is as capable as the geothermal industry to scale and to accelerate and to help grow the business is this oil and gas sector. If they do it, I'm not convinced yet. I'm not convinced yet. 80% of our energy consumption is based on oil and gas and coal. Now, coal is being sort of gradually phased out, unless there is clean coal these days, but it's going to be phased out. But oil and gas is here to stay. There's much money invested in oil and gas over the past century and in the coming 30 to 40 years to come. So in that sense, it's maybe wishful thinking. And at the other side, I also hear from Dr. Biro from the International Energy Agency that the time has come for oil and gas to basically phase out. Not now, not in 10 years, but in 20 to 25 years. And that's exactly, let's say, the window of opportunity right now for the oil and gas sector to think about, because typically you invest 7 to 10 years upfront. And hence I do think the oil and gas sector is the one. I'm not convinced yet. I'm very curious what Rolf thinks, because he said something about marrying as well with the oil and gas sector. But I do think there is also a lot of opposition of working together with the oil and gas sector because of the polluting aspect and the fossil fuel lobby, etc. But I am convinced without oil and gas professionalism, we cannot scale at, let's say, the biggest dream that we have and the biggest ambition that we have. We cannot achieve that without the oil and gas industry.
Thank you.
I have not much to add, but we didn't have any oil and gas companies in Iceland, and we succeeded. I think governmental support is, of course, very much, appreciated. Making the rules, making the playground, fair and square, and all those things, and come with some money. I remember we had a problem in 1957, so the government just bought a new drill rig, the steam drill rig that drilled all our wells in the 70s, and that really made a difference. So I think a government support is needed, as well as on municipality level.
Right.
Just quickly add to this.
Yes. Quickly.
I fully agree. Yeah. And at the same time, I totally disagree. Because, let's be honest, the reason why we're talking about a geothermal boom in Europe is because of sedimentary basins. To reflect on what Inga Mørk was saying this morning, it's all about the play analysis. It's about the geological provinces. And that there is a shift from the volcanics to sedimentary basins and even go deeper and bolder and beyond. That's not the typical Icelandic expertise, is it? So that you're doing exciting things with also what Hjalti always talks about in this fantastic Krafla-magma. Fantastic. So you don't need oil and gas there. I completely understand. But here in Europe and in the US and in parts of Malaysia and in Africa, for sure.
Thank you. We're very quick. We're out of time, but please share.
I think it's a mix of technologies. I'm going to be Switzerland here. Say it's a mix of all these different technologies, but I think it always comes down to policy and regulatory framework to begin with, and then trying to mix everything together.
Yeah, I agree with you. So I'm Switzerland as well. But we can continue this discussion. I guess there's coffee break very soon. We have a lot of questions. I'm not sure we have time for that. I'm looking at you. We don't have time for that. But we have a coffee break. So please continue with the discussion and the questions in the coffee break. I'm not stealing your words here. I wanted to ask the panel a final question. I'm not going to do it. But I'm going to leave you with the question because it's a 30,000 feet question. It's why geothermal? So thank you all for listening today. And thank you.
So, as Birta said, there is coffee outside, and please take some re-energize, refresh, and we will be back on at 4:15. So, welcome back for our final panel of the day on the role of CCUS technology in the energy transition, moderated by Dr. Jürgen Petersheim. If the panel and the moderator, please have a warm welcome.
Coming up. Yes, good afternoon. Last panel of the day, always a bit tough, but I promise it's going to complement the others pretty well, and you will have some new information, get some new insights on a very relevant topic, I feel. Carbon capture utilization. So we'll talk about this in a minute. Let me just give you a brief update on, or let's say a short introduction, really. The energy transition itself, I think there is no silver bullet. So it's sort of like a puzzle with different pieces you have to get together to get it right, to come to net zero. And what I think, so the first piece I think is sufficiency, so consume less. Then we have the efficiency part, so basically what we consume, we better produce and use as efficient as possible. Then we come to, let's say, the renewable energies. I mean, we heard a lot about geothermal today. There was mentioning of offshore wind occasionally. You know all the other ones. And then last but certainly not least, we have the CCUS part, basically carbon capture and utilization. The technology has been sort of tested in the energy or the power sector for quite some time. It looks like in this particular sector, other options emerge to be more beneficial, but for the hard-to-abate sectors, think steel, think cement, think chemicals, transport fuels, particularly aviation fuels and shipping fuels, CCUS is going to play a major role. So, and I read this article in The Economist recently, and it states, can carbon removal become $1 trillion business? And that's exactly what I want to discuss with my fellow panelists here today. Ideally, I'd like to give you each a word quickly to introduce yourself, so that before we jump into the topic, we get to know a bit what your company, what you're doing. And Christiana, let's start with you, I guess. Your introduction. So just a quick word about you.
So my name is Christiana Christiansdottir. I'm the Chief Commercial Officer for Carbon Recycling International. We're a company offering a technology solution and have been in the carbon utilization space for over 15 years. So we know the space really well before it became a trend and a hot topic.
Yeah.
Good afternoon, everyone. My name is Anastasios Perimenis. I'm actually Greek, so if the Dutch person was feeling weird in this panel, imagine myself going on the other side of Europe. I'm the Secretary General of CO2 Value Europe, which is a Brussels-based association, and it is representing the carbon capture and utilization community in Europe. And we will discuss what this means.
Hi, my name is Sultan Elek. I'm CEO at Landwärme. We are a biomethane trader, so doing something completely different, providing renewable natural gas, renewable methane. But doing so, one part of our process is converting biogas into biomethane. We do this by carbon capture. So carbon capture has been around with us for now over 15 years, and now we are starting to utilize the source of CO2. In just our portfolio, it's over 1 million tons of CO2 we can provide for utilization or also for storage projects.
Welcome, everybody.
All good?
And I hope everybody's fine over there. My name is Mark Rüggeberg, and I'm working in the Volkswagen Group, in the Group Innovation, and we focus on CO2 economy, which means like the CO2 topic itself as a whole for the calculation of business cases in terms of value for the group in the supply chain and all the products. And we've been focusing on this as a group since 2015, but in the department I'm heading in 2019.
Hello everyone, my name is Kristinn Ingi Lárusson. I'm from a company called Carfix. We turn CO2 into stone. So we've been doing that since 2012. My role there is I'm heading commercial strategy and business development. So in short, this sparkling water here, we are pouring into the ground, like Mother Nature has done for millions of years, where it stores and remains for millennia.
Excellent. Well, thanks for that. And I feel we have a pretty good, let's say, a broad panel of sort of OEMs, technology providers, sort of users, and then Anastasios with the regulation part. I'd like to arm you with a few facts before we start the discussion. So recently the US Department of Energy stated that by 2050 we will need to sort of CCS capacity within 400 million to 1.8 billion tons of CO2. If you extrapolate this across the planet, we'll be talking about something like 8 billion tons of CO2 annually by 2050. If you want to meet this target, we would have to invest within this decade $150 billion, so a lot of money. And for $150 billion, I think as a industry and technology, you have to provide some unique benefits. And I'd like to get your views on, and maybe let's start with the technology providers, but what do you think is a unique benefit of CCS that makes it a relevant complementation of the renewables?
So in general, I think the CCUS as an industry is in its infancy. So we are literally taking our first steps towards something that will be big. I think everyone is realizing the seriousness of the issue, the problem we're facing. And the fact of the matter is that we don't have time. We have to act right now. So policy being the biggest obstacle, I use that word, very strong word, but it is slow in reacting. It can't do much better. In regards to the numbers that you mentioned before, it's estimated in 2050 that CCUS will need to, on an annual basis, to store and utilize between 5 and 8,000 million tons of CO2 per annum. Just to put it in perspective, last year, 40 million tons were stored globally. So there's a big shift from 40 up to 8,000 million. So the seriousness of the issue is extreme. So again, we have to act right now. There are tools available within the storage, within the capturing, and within the utilization. It's a matter of just do it, make things happen.
Mark, do you see it similarly?
Yeah, from our perspective on it's, we started with a decarbonization, as we call it, on the parts for avoidance, removal and compensation of CO2 emissions in 2015, because we saw that there is a rising penalty situation, I would call it. So you have to pay for each ton of CO2 emissions, and the price is rising. So for a company, it is a business perspective that you want to take care of to see where are the prices developing to, and what are the measures you can do against it, or how can you deal with such an uncertainty or such a risk. And there are different measures, like for example CCUS, that we investigate. And see, is there a potential that we can avoid paying penalties to the like the state or like the government? Can we use or utilize a certain technology in order to make business out of it or to make it run? And how can we deal with it? And as a group, it is always for us, with more than 670,000 employees, a very challenging task, because it's a lot of products, but also a very big footprint behind it. So it is a task we have to calculate, very, very feasible, and to make it work, we cannot spend too much trials, I would say. So that's why we look into this whole picture and evaluate in the first step before we make the choice And again, I have to repeat like other speakers, it is a matter of the regulation and to set the clear boundary conditions for every industry, I would say.
Mm. I mean, regulation was mentioned twice. We'll come back to that later as a bit of a deep dive, because I'm pretty sure you have some ideas on your wish list, let's say, what to improve. Zoltan, what's the unique benefit of CCS for you?
I think to really face climate change, the challenge we have there, we have to restore carbon's balance of the planet as it was 150 years ago. So it's not enough to cut emissions by 80% or 100%, but we have to start a phase, decades or even centuries, where we take CO2 out of the atmosphere. And in the end, it came from fossil places, so where we took the natural gas out of the coal and we put it down underneath the earth again. Beside that, there are going to be different applications. We're going to have usage cases, we're going to have e-fuels and so on, but this is going to be in the range of million tons, 100 million tons of CO2, which we can utilize in industry and application. But most of it is going to be storage. And I think it's completely okay to start now, because we have to ramp up this industry and not to wait until we have finished the task of reducing emissions. And at the end, I think from an economic point of view, there's going to be like a point where reducing emissions gets so expensive. If we try to fly renewable today, if you try to produce renewable air fuels, this is so expensive. We're talking about cost of over 1,000 tons of CO2 reduction. It's much more easier to direct air capture and store it, do something with bioenergy where you produce energy at the same time and have CO2. So this has to be, so I think people are starting to see this big potential, and it can start to grow, because it doesn't matter where it happens. It doesn't matter where you take the CO2 out of the atmosphere. It doesn't matter where you store it, as long as it happens. So it gives a big chance for globalization also. It's something, I think, because we are here from the Iceland perspective, there's a big chance also for places on the earth where you have energy and perhaps also storage capacities, but you don't have the interconnection. Well, you can do this service to humanity and take CO2 out of the atmosphere and send the bill to US or Europe and live from that. Yeah.
Thanks for that, Christiana. As a technology sort of expert or supplier to the market, what do you think is your specific benefit offering the net zero agenda?
Yeah, so in terms of how CO2 utilization can complement the renewable energy, and in essence, it's this massive, I mean, governments have set net zero goals, which are going to be achieved. And this is requiring an unprecedented energy transition. And to be able to do that, there are a lot of changes which need to take place, and it includes the replacement of fossil-based sources. And these are carbon-based, and you have to get the carbon somewhere. And our technology solution offers that, and it's already been deployed, utilizing captured CO2 for the production of methanol. And methanol is a fast-growing market. You've already seen it a lot in the news. The marine sector has already taken it up. You already have ships under production, which are going into that field. The EU has already set in place regulations requiring mandates for synthetic aviation fuels, and these are expected to come from the utilization of carbon from direct emission sources, because that is the more energy efficient way to capture that carbon.
And maybe Anastasios, I mean, you have a sort of more of a regulatory policy lens. So, what do you think? Why would regulation drive CCS? What's the unique benefit?
So, first, a small note. We sometimes put the terms together as CCUS, and it's often confusing because the business models are different. Some parts are common, like the capture part, but the overall idea of CCS is a little bit different than CCU. It's a little bit different than CDR. So I think we should talk about the terms by distinguishing them, because the environmental impact can be also different. CCS is a linear approach. CCU is a more circular approach. So the regulation, I'm going to make the surprise here and not say necessarily that the regulatory framework is a barrier or an obstacle so far. We've heard it before. It's a very important aspect, but this couple of years there has been an unprecedented effort, a regulatory effort at EU level with a Green Deal, with a Fit for 55. There is 20 at least instruments that have been revised or new instruments coming into play. So the regulatory effort is there, and it is important because this will give the certainty, the legal certainty to investors that are ready to invest in upscaling those technologies. As Christiana said, there are regulatory instruments on the downstream for aviation that says, for example, 35% of fuels in the aviation sector by 2050 need to come from synthetic aviation fuels, which is another word of saying CCU fuels, basically. There are similar instruments for the maritime sector, Fuel EU Maritime. There's a renewable energy directive that opens up the route for those products also in industry. They use a fancy word there. It's called renewable fuels of non-biological origin, RFNBO. And there's the ETS, emission trading scheme, that has been revised also to complement the CCU and the CCS. So there is the effort, the regulatory effort is there. I think even more important is that these 20 plus instruments, first of all, they are consistent, and that the one does not provide targets that another one might make more difficult to achieve them. Because, for example, you cannot access one particular source of CO2, or you cannot access the renewable electricity that you need. So this is one important step, that the regulatory framework is consistent and that it allows in this decade the upscaling, the first of a kind projects, the second of a kind projects that will truly show the potential of these technologies.
You rightly started separating into CCU and CCS. So I think from the application and sort of carbon abatement potential, or let's say pathway, maybe Mark, I guess you have a good overview of the different CCUS technologies. So how would you see CCU and CCS develop? Is there one going faster than the other, or what's your feeling?
I would answer. Currently, we see that the CCU sector, there might be a pathway. We started with a Porsche project down in Chile. The e-fuels production in a, of course, pilot plant, but it is the first step for commercialization. So I would say we take the chance on the CCU part, because there are some, as Anastasius already mentioned, there are some regulatory efforts already been made. And we see that in the future, in the supply chain, there will be additional CCS need. And this needs to be regulated and officially acknowledged in the European Union, that you can apply those different technologies and work with it to, of course, drive down the remaining footprint of the supply chain, for example. And what we did already with, for example, electrification in the passenger car vehicle is that we took a giant leap in terms of decarbonization, the major footprint of one specific part, but the remaining part is like in a different scope, like the scope 1, 2, 3. So there is the supply chain we have to take care of also, and so it all has to take means in all those different playing fields, I would say.
I know, makes sense. And Christiana, you are on the CCU side, you are fairly active. So, I mean, you mentioned methanol. Do you think this is going to be the main application in the short term, and or SAF complementing? And is the CCU space or applications going to change over time? Do you see what we produce today in CCU, we will produce the same in terms of in 2040, 2050, same products?
Do you mean the same amount or the
No,
same?
not the amount. The volume is hopefully going to go up. But
Okay.
in terms of end applications, so today, let's say methanol, SAF, will that change in the future? Could we see other materials being produced?
So SAF is something that is maybe not the shortest term goal. I mean, you have some few regulatory or not regulatory barriers, but also just approval barriers for the technologies in terms of it being used as an aviation fuel.
Yep.
So that's maybe a little bit longer term, but still probably shorter than we expect. I mean, technology develops continuously, right? So you'll have technology development over time. There will things that will be possible which we can't even imagine. So hopefully, but there is significant interest, and being a company that has been in this space for 15 years, and I've been with the company for 10 years, I see a huge change. And even in the past 2 years, the dramatic demand for methanol, and not only in the chemical space, which is a space that, methanol is one of the most versatile chemicals used globally. It's used all over you in your daily life, in paint and glue and silicones and fleece, and you might have heard of it until it was discussed as a marine fuel. But this is one of the most fast-growing spaces, and the IRENA reports forecast that methanol by 2050 will have increased by 400%. And this is due to the energy transition and the growth in the green methanol and the low carbon methanol space. So yes, long term, probably there will be change that I can't even predict. But short term, I mean, the growth has been significant just in the past 12, 24 months.
It's also something we see, that methanol certainly is going to come. Yes, it's used in every day, almost every part of our life. Zoltan, on utilization, what do you think? Do you agree with Christiana on the applications? Or do you think there would be other possible routes as well for CCU?
I think we're going to, first of all the fossil CO2 sources we have today. So really reflect on that. So we are currently really digging CO2 out of the earth. So there are natural sources for CO2, fossil CO2, and we put it into water. So we have to replace every fossil CO2 sources, first of all, in the current applications, because there are applications for CO2, but the amounts are tiny. I mean, 3 million tons in the European Union. It's not the game changer here. The next one is something more like chemical industry, so methanol, but other applications, so everything which is where we produce plastic and stuff like this, which is mainly based on oil. Could be a big application, so now we're talking about several 10 million tons of CO2. And then the final decision is, do we take CO2 as a carrier for hydrogen? So do we go the path of e-fuels or not? This is something, I think it's a technological question, it's an economic question, and in the end, politics have to decide. So if we don't leave out the e-fuels, utilization will be always a small part of the whole carbon business.
Sure, Christiana.
I would like to correct that, because methanol today is 100 million ton globally. Yep. But even for Europe, I mean, most of our production is made elsewhere. That's why our carbon footprint is lower, and we can't forget that. We can't dismiss the fact that we've lowered our carbon footprint, but we simply moved our production somewhere else. And that can't be forgotten, and that's part of some of the regulations and policies which are being put in place. And maybe you can add on that. But the chemical industry is a huge market already today. And populations will grow. And with that, there will be also growth, or some growth of consumption as well. And all of this plays a part. And there are even a lot of processes which are being developed even further today, like methanol to olefins and plastic processes which are being looked at in both home care products and cosmetics. So even your, L'Oreal and Christian Dior and Yves Saint Laurent, they're already looking at different paths for packaging. So even routes where methanol wasn't used before is being looked at today. And we know that because we're in the full value chain of the space as CRI.
And maybe Anastasios, on, let's say, offshoring emissions, sort of any comments on that?
Sorry, on?
On sort of moving production elsewhere. I mean, that should not be the end goal, because it's not helping the climate really. So what do you think regulation should do?
From a regulation point of view, there is a specific instrument that will come into place and that will avoid this, let's say, moving effect. It's the carbon border adjustment mechanism. It will apply to some products that it's kind of a tax, a border tax for importing in Europe products that are made outside Europe with less attention to environmental impacts. But this is not only the issue. The point is that we need to be able to keep in Europe the clean tech technologies that we have know-how of, and that means that we will need to be able to valorize all emission streams that are available now to produce precisely those products before going and seeking those emission sources somewhere else and producing those products somewhere else. So it is important to be able to valorize through those technologies, like CRI's technologies, like carbon technology, in areas in Europe where they are available. And this is a crucial part, especially for the first of a kind, the newcomers, that they have this certainty that their emission sources can be valorized into a marketable product that will replace a conventional fossil product.
Yeah, no, absolutely. I mean, finding, let's say, these off-takers. I went to a cement facility recently. They put in the first carbon capture facility and turns it into formic acid because they can sell it to a customer. And they actually get paid well for this and manage to get the capex to realize this project. Kristin, I mean, you're in the mineralization space of CO2. So storage, how do you see this market developing? What do you think is going to happen in the next, let's say, 5 years and then moving forward?
Well, I think, as I mentioned before, the significant change from 40 million up to between 5 and 8,000 million per year, that kind of summarizes the potential of the market. For us, we have been granted funding from the European Innovation Fund, building the Coda terminal in Iceland. That's going to be the world's largest mineral storage site. We will be importing CO2 from mainland Europe, from emitters, for example, here in Germany, with large tankers in a liquid form, where it will be, mineralized into the bedrock in Iceland. This is, again, a new industry in the making. So this project alone is estimated to be creating somewhere between 800 and 1,200 jobs while being implemented. So, but this is first of many. This is going to be 3 million per year over a period of 30 years. That's 90 million in total. That's still a tiny portion. So that's point-to-point terminal. We are looking at it from it will always be more economical if you can actually utilize at the same site as the actual emitter is. So for example, here in Germany, if the bedrocks are feasible, it will always be most economical to do it here. We are introducing a new technology, actually the oldest technology ever, because this is Mother Nature. So we are simply replicating what Mother Nature has done for millions of years. So I foresee that, and the statistics and the figures, for example, from the International Energy Agency support that. They estimate approximately 1,000 billion tons need to be avoided in the next 30 years. That's for the entire, energy transition. And the CCUS is only 12% of that. And storage is 90% of that. So it's a huge problem. And I cannot, put more emphasis on it that we have to act now.
Absolutely, absolutely. So it's, yes, there's 40 million tons today. So let's say the CAGR or the growth rate is significant. And it sounds a bit like, the solar industry 20 years ago. So starting to grow. what we've seen in the solar industry, I mean, we have seen spectacular cost reductions of solar generation, of wind generation. When you look at the literature for CCUS, I think we start seeing similar trends. You know, a few years ago, we saw abatement costs for CCUS of, let's say, $600 per ton. This is coming down. Latest numbers, there's a broad range. You find everything from $50 to $230 per ton. So costs are falling. What do you see technology costs? And maybe Mark, because you have a broader overview. What do you see? When do you see CCUS and maybe start separating CCU and CCS into being economic or being in the money? What time frame?
My background is manufacturing technologies, indeed, and I can completely agree to what you say, because so far as we see it, the basic technology is on a very high technology readiness level. It is currently only pilot projects being deployed. First bigger projects are already started or facilitated, will be up and running by the end of this decade. So we see first projects getting in a commercial sense, or will work business-wise by the end of this decade, when the first projects will be deployed in a number where you can scale things. So you don't have like manufacturing on like it's highly automated manufacturing technologies you can apply, for example. You will see similar cost reduction as in the other industry sectors, like the production of, for example, PV costs. So to our understanding, it will happen by the end of this decade. And for us, I would add, I agree completely with Kristin, is if you look at the market, CCU and CCS, we see that there is already on this planet such a big number of investment put into place for infrastructure and to operate all that we are consuming daily. And we are producing daily more polymers, more fuels and so on. There's a growth in the fuel consumption, because mobility, which is a topic I heard in the morning, the limit on the highway. I would say let the market regulate the pricing for the technology, because the market will develop. It's like the lithium-ion cell for battery. It took some time, but at a certain time it was very convenient, and everybody saw there are major advantages, like in the mobility sector. You don't want to get penalties all the time. It's what you do with your children. You give incentives to the children, and they will learn much faster. And that's what the US, or for example, in comparison, does. The European Union or the ETS, it gives penalties. The US, for example, gives incentives. So the money will go the way where it's attractive, most attractive to the companies. And then you can get advantages from both parts. Like the decarbonization doesn't have only disadvantages. It has some major advantages. For example, not only lower footprint, but if we switch from coal-fired power plants to gas-fired power plants, for example, we had cost reduction also. Of course, there are some outer circumstances we cannot influence. For example, the war in the European Union from Russia, it interfered, so we had to switch back to the coal-fired power plant, for example. But again, we see a shift. First, the utilization of carbon dioxide But in its wake, we cannot wait to build up the infrastructure for the storage part.
Yeah. I think I agree, infrastructure is key to get this right this year. So, but coming back to when is it going to be cost competitive? So you say, let's say late 20s, early 30s. So sounds a bit like the hydrogen area. So we hear similar timeframes. Zoltan, do you think this feel the same around the early 30s?
I think if you look at the sources of CO2, you're going to see a cost curve. So there are potentials, and we have today sources at the biogas plants where we have the CO2 for free. The only issue is you have to liquefy it and bring it somewhere. So you have a lot of logistics. So liquefying it, 20, 30, 40 euros a ton. Transportation depends where it goes. If we send it to Iceland, it's going to add some additional cost. So there are sources which are very cheap, and there are going to be sources which have huge potential, like direct air capture, which will have a much higher level of cost. But I think we can start off with the industry by tapping these very cheap sources, which is especially in biomass, but also in new applications where we grab fossil CO2 directly. For example, if there is a steam reformer to produce hydrogen, that are good opportunities. And I think we see a lot of movement in the market because ETS at a level of 90, 100 euro, it's tapping. It's reaching that level that a lot of applications can run on that. So we can pay money to transport CO2 to Iceland, even more. And this is the opportunity. So we reached already a level in the market where it works.
Okay.
But not for all applications, but it's going to be the starting point.
So you say a niche market competitive today?
Yes.
Okay.
And growing bigger if you reach like 100, 200 euros per ton of CO2.
Okay. And Christian, I mean, you know the numbers best as a technology supplier. So what's your feeling? Are you between niche market today and late 20s? Maybe Christian first and then Christian.
So there are already plenty of opportunities which can be taken advantage of today. They won't be all, but the main cost factor which drives the decision for sites is not the CO2 price. It is the energy price itself. So it's the energy transition, the need for additional energy. This is the main cost for, at least for our technology. And even if you're producing it into hydrogen, the main cost driver is the production of hydrogen itself. And any of the solutions which are being spoken about for e-fuels use hydrogen, and that is the main cost driver. So whether you're talking about methanol, hydrogen, ammonia, hydrogen is still, and therefore energy is still the main cost driver. What makes it unique for some of the projects which we've already are in operation, like the plant that we have in China, which is 110,000 ton production capacity, which is already operational, and a second plant being operational with 100,000 ton capacity in a few months, is that the hydrogen being used is a waste hydrogen. It is a byproduct stream from an already industrial source, and therefore it doesn't have the same cost factor. So you can immediately, and that methanol produced is a low carbon methanol, and it goes directly competitively into the market already. And there is already significant interest from the market in tapping into that product as well. Mm-hmm. And these are kind of the immediate steps. We mightn't be able to do every optimal solution or utopian solution immediately, but there are plenty of solutions which are ready to be deployed today and can already have significant impact. And the plant that we have in China is a good example of that, because it's 110,000 capacity, it uses CO2 for the production, and it replaces coal-based methanol. So it saves about 300,000 to 400,000 tons each year by replacing a coal-based methanol. So there is a lot that can be done immediately.
Yeah.
If I can kind of add from the storage part of it. So just to, as Mark said earlier, it's sticks and carrots. Meaning in Europe you have the ETS, and in the US you have the carrot that everyone is chasing. There is a market for, it's not yet a full commodity, but you have an ETS market, and the price for the ton is approximately 100 euros. So that's the incentive, or let's say the stick that companies will move ahead. Yeah. So that's a driving factor. But if we look at the value chain, there are four components for us. There's the emitter, the capturing, the transport, and then the storage part. So we are, of course, in continuous dialogue with all these parties within the value chain, again creating a new industry. So everyone is doing it for the first time. So the learning curve is very, very steep. There is, from our perspective, you have to remember we've been doing this similar as Christina was saying. This is not something that we are coming out with now. We've been doing this on a commercial basis since 2012. The cost for us, the entire value chain on power site, geothermal site in Hellisheiði, is less than $25 per ton. That is the capturing, the transport, and the storage, and the OPEX. So that is a number that is already in the green by far. So using the parameter as a 100 euro, but then again, to complex it even more, you have the voluntary market, which is the bio, the BECCS, and DAC, direct air capture. And then you have the mandatory market, which is ETS. So you have two different drivers as well. But from our technology, it is already in the green zone, if you want to say.
Okay, so I mean, I take away certain applications in the green or in the money today. Broader, let's say, commercial competitiveness by 2030. Anastasios, we mentioned regulation earlier. What do you think is needed from a regulatory point of view to get to this broader market uptake? What would be a wish list, basically?
Consistency. So if you have an instrument that puts quotas, for example, for aviation fuels, then have an upstream instrument also that allows you to be able to cover those quotas and not limit electricity availability, not limit CO2 availability, not limited sources that you can use. So consistency is one. For me, the most important part in this decade will be upscaling. And instruments like the Innovation Fund, for example, one of the largest innovation funds in the world even, with 10 years of operation, funded by the ETS allowances, and putting a lot of focus on clean technologies like renewable energy production, energy storage, CCU, CCS. So these instruments need to bring an ecosystem of funding, both private and public funding, for those first comers that can de-risk the investment, and in conjunction with a regulatory framework that will be certain and will provide this legal certainty to investors, then we can see the upscaling taking place. And most of the large-scale, industrial-scale projects that have been announced on CCU with capacities of around 200 kilotons per year, for example, they will be operational in the next 4 to 5 years. And for those projects, they will be the drivers for all the second of a kind, third of a kind, and the wide replication that we will need to make the products that we will need out of non-fossil carbon. So consistency in the framework and investment for upscaling.
Okay, maybe thanks for that. Maybe with just 2 minutes left. Coming back to this, can it become $1 trillion business? So, if you had a wish each, what do you think? What would be the most important thing to get CCUS to this $1 trillion business? So, and maybe short. And
I think I just said my wish list.
Yeah,
so.
You started. I was thinking about not asking actually. Yeah, okay. So, Christiana, maybe you're next.
Actually, I quite like your wish list.
That works well with the timing, actually.
Yeah, I mean, I think you kind of hit the nail on the head. I mean, it's important, and it's important for investment. You have to have consistency because that de-risks, right?
Absolutely.
And you have to, and this plays also into evening out the balance of ensuring that there is a shift in the status quo of the cost of fossil-based sources and kind of transmitting that exponential cost to society into the price of continuously using it. So actually making that shift to make sure that it is a preferred choice to use the alternative solutions which lower the overall carbon footprint of the world.
Okay, Zoltan, what would be your one wish?
One wish, if on the long run, if we take the income we have from ETS and other emission taxing system and pay for those who take CO2 out of the atmosphere and put it underground. So if we have two markets, one for negative emission and one for emission reduction or whatever.
By the way, you will have with the carbon removal certification mechanism in the future, in the coming days. It's not here. It's not here.
Maybe Mark quickly and Christian. So
very short, the acknowledgement of the carbon source to get utilized in the utilization and or storage part.
Makes sense.
Yeah, I will be very quick. I will say education, educating people about the importance of having things, where we stand, because that will push them even further. So.
Excellent. Well, thanks for that. These 45 minutes went quickly. Yes, thank you.
Excellent. Thank you, Professor Peter Simon, and dear panelists. And now for closing remarks, please join me in welcoming Not Thorberg. Please, Not.
Minister, Ambassador, and Your Excellencies, and dear friends, since we're in the Nordic House, and I've heard the word partners coming up so many times today that I must say, dear friends, what a productive day it has been. I would like to start, before I summarize, just briefly before we join in the reception later on here on the second floor. I would like to start by thanking everyone who has made this day what it is. On behalf of the Embassy on Green by Iceland, Business Iceland, we send you so many thanks for participating in the event with us as guests, as well as contributing to this valuable dialogue that we've had today. It's been so amazing to listen in on the two national teams that have joined forces today. And I could say, it's been a great match. It's a 1-1, isn't it? It's an even match. It's an even match, absolutely. But if we go just briefly into the key takeaways that we have, taken with us from today, at least from my viewpoint, and I'm sure that you will have more to talk about later on at the reception. Well, obviously, the climate crisis has been discussed, but one of the key topics that has been brought up is the fact that we are also, of course, experiencing difficult, challenging times in Europe. And energy is really also a matter of security and independence to some extent, just like Iceland's case shows, and the story that we can share. Of course, we've set very ambitious goals, both countries. We aim to reach carbon neutrality by 2040 and 2045. Time goes really fast, and as Minister Habeck mentioned, it took a lot of time to get to the 50%. And it took, of course, many decades for Iceland as well to achieve that target to 85% of primary energy. And of course, if we think ahead, the key to climate changes, or to climate change and to the crisis that we are experiencing is renewable energy in all shapes and forms. And we've discussed so many solutions here today. And in my view, it's not only the green transition as such, it's also the green transformation, and it's been brought up so many times today during our discussions. It's finding new solutions, new technological solutions, but also changing the processes and the way we think and the way we approach things to society. All things matter. And on that note, we also heard that social acceptance is important, and communications. Communications will help us also communicate the important goals that we have set and the vision that we share for achieving a green future. So we've heard so many ideas on how Germany can unlock the full potential, especially when it comes to geothermal. And not to say, of course, now this great discussion we had on the CCUS technologies, which of course are, well, breakthrough technologies that might even help us accelerate and reduce emissions even further. So we could hear that there is a shift, it seems, in interest towards geothermal, and there is, of course, a great shift also towards just opening our horizon towards all the great technologies that will come together to enable our path. And when it comes to Germany, of course, one of the biggest opportunities that was highlighted today is the direct use of geothermal and the cascading uses that can bring so much more value and even quality of life, like Iceland's case example shows. And just think of the opportunity. Minister Habeck, he mentioned in his speech today that house heating accounts for 30% of the emissions in Germany. And I think the house heating proportion in Germany is about 30% as well of the energy need in Germany. So imagine if we were only able to take geothermal, 25% of that, and what a difference that could make. Huge difference. And of course, it's a big, big challenge involving 40 million homes, involving a lot of bold decisions. But that was the path Iceland took. It wasn't always an easy one, but it was a path which was taken with a long-term perspective, and it brought a lot of value. And that is the crossroads that Germany stands before right now. And of course, it's been highlighted today that we can and we aim to become great partners together, and we can work together because together we will go so much faster. And we can work together when it comes to the geothermal ramp-up, in terms of policy making, building knowledge and skillful resources as well. We heard the figure 700,000 people would be required just within geothermal. And of course, also when it comes to communication and execution of all the projects in the pipeline. We can work together also when it comes to scaling up and developing the CCUS technologies and partnering up on research and policy making and creating the framework for those technologies to, be able to scale up. And then, of course, I'm super excited also about the super hot magma groundbreaking research that Minister Guðlaugur Þór mentioned. And when he mentioned it, I actually thought super hot rock, because we also heard this morning, of course, we have heavy metal in the house, so now we have geothermal rock in the house. And there are opportunities on offshore wind and e-fuel technologies, of course, also between Iceland and Germany. So there are so many opportunities, and to all of you, I'd also like to say that there are 8 billion reasons for this to happen. So the time for action is now, and so let's work together, and let's make this day the next chapter of the prosperous collaboration between Germany and Iceland. So let's push the boundaries together. And maybe this is the new energy era, energy solutions era and collaboration between the two countries. Who knows? The time will only tell. But I rather much like the slogan from the video, Varme for alle. I would like to add to that, future for all. And after all, you know, it is our climate future and for the generations to come. Thank you, and I invite you to come now to the reception, and let's even continue now to discuss and explore